Swimming Pool Steve here, coming to you live from what used to be my test lab. These walls would normally be covered with pipes and instrumentation for reading flow and how much electricity pool pumps use, stuff like that. And it was really cool for a long time. I filmed hundreds of videos. I think they're really useful. They've been seen by literally hundreds of thousands of people by now. So you know what? Let's go ahead and take this to the next level. So what do I mean take this to the next level? What am I going to do here? It was actually looking pretty complicated before. If you've seen some of my videos, it was kind of like a wall of plumbing. It looked pretty impressive to the average homeowner or average swimming pool owner. This one's going to be a lot more complex than that. What we're going to do here is a standard configuration, which is known in the pool and spa industry. It's a shared pool and spa system. We're going to use one set of filtration and heating equipment, and we're going to operate two different bodies of water, both a hot tub and a swimming pool. In doing this configuration, this is one of the more complex plumbing configurations that you can get for swimming pool and spa systems, at least on the residential level. And when you see these systems in person, if you're not a plumber, they're pretty intimidating to the average person. So we're going to build one together, and we're going to remove all of the mystery. You're going to see exactly how they function, how they go together, how it all ties together completely, and then how you operate those systems. Further to that, we're going to take another step. We're going to automate everything. So that means no more going over there and turning valves like a caveman. Just pull out your phone, type in the temperature that you want, push a button, valves turn, isolates the hot tub, fires up your heater, gets everything ready for you to jump in the hot tub. This is the gold standard for swimming pool and hot tub systems on the residential level, and we're going to do the whole thing together from beginning to end. It's going to be awesome. I'm excited. I can't wait to see this. Gus is excited too. This is going to be good. Stick around. Before we get started installing all of this equipment, I want to take just a moment here and thank the sponsors that made this video possible. Hayward.com. We make backyards better. Hayward is committed to crafting superior products that never ask you to compromise value for performance. Jandy.com. Everything you need for the perfect pool. Jandy has a clear mission to create the perfect pool and wellness experience responsibly. H2flow.net. Know the flow. H2flow. Engineered solutions that measure flow, prevent drain entrapment, and reduce energy consumption. Weld-On.com. The world's most trusted bond. Weld-On makes the world's most reliable plastic pipe joining products for demanding professionals who know trust can't be compromised. Well, here we are. Honestly, I'm exhausted just from bringing this stuff in here. I sure hope you're liking and subscribing. This is one heck of a lot of work for me to do if you don't like and subscribe. So we're going to do a shared pool and spa automated system. And so that means that both the pool and the spa are going to operate from one set of filtration and heating equipment. And then in addition to that, I'm going to have a second pump for booster pump for massage jets, water feature, that sort of thing. We're going to have an Omni PL automation system. It will have a salt chlorinator. We've gone with a HydraPure, Hayward HydraPure AOP system for peripheral cleaning. The pipe size is going to be large. The booster pump system is going to have a 3-inch suction, 2.5-inch return. The filtration system is going to be a combination of 2-inch and 2.5-inch throughout the trunk line. A lot of bypasses. We're going to have a ton of instrumentation here in both analog flow meters, digital flow meters. I'm going to have wattage meters, amperage meters, inductive amp meters, a bunch of different ways to monitor flow, electrical consumption, things like that. It's going to be pretty busy in here. As you can see, there's an awful lot involved with these systems. They're not simple. This is a fairly complex swimming pool and spa system that I'm going to be installing here, and I'm going to take you along for the ride. It's going to be great. It's going to be tiring, but it's going to be great. So running through the room here that you see here, just from beginning to end, to give you an idea what we're working with, we've got some 2-inch flex pipe, 1.5-inch flex pipe, 425 square foot Hayward cartridge filter, 150 square foot Hayward cartridge filter. Weld-On is going to be the brand of primer and solvent cements that we'll be using throughout this installation. On the ground there, we've got some Hayward motorized valve actuators. Next to that, we've got a Hayward 40,000 gallon salt chlorine generator cell. Then we get into an assortment of Jandy valves here, three-way diverter valves, straight diverter valves, 3-inch, 2.5, 2-inch in size. We've also got an assortment of check valves, corrosion-resistant check valves, also from Jandy. From H2flow, we're going to be installing FLOWVIS flow meters, both the analog flow meters as well as upgraded digital readouts for those flow meters. That's going to be fantastic. And from H2flow, we also have the LevelSmart system, which is a digital controlled automatic water filling system for your swimming pool. So that's going to be great. We're going to be including that as well. We've got a Hayward HydraPure AOP hydroxyl radical generator. I've got an assortment of pipe ranging from 3-inch, 2.5, 2-inch, and 1.5 in size, Schedule 40 rigid PVC, pressure rated of course. Then on my other side here, we have the Hayward Omni PL Plus panel, which is what we'll be installing, plus an assortment of the different types of control interface that you can use for an automation system like this. Of course, you could just use your phone. That's what most people use the app on the phone. But there's also a spa topside control. You have the wired keypad, and then you have the optional battery-controlled remote keypad that you can walk around with, bring to your poolside, that kind of thing. So we're going to be exploring a ton of different equipment, multiple pumps, multiple filters, peripheral sanitizers. We're going to automate everything with motorized valve actuators. It's going to be high flow. It's going to be actually low cost for electricity, and we're going to be monitoring all of that stuff. This should be a very well-designed, hydraulically efficient system. Not overly so. I'm not trying to design for efficiency. I'd probably need more space here to do so because there's a lot of equipment in a small space, and so I have to be fairly tight with where I install it. Likely we won't be seeing much in the way of sweep elbows on the pad. People will probably comment about that. Short radius 90s are perfectly fine to use. Use them sparingly. Don't use 10 of them back to back. You know, be smart with the decisions that you make. And these are all stuff, they're all things that we can talk about during the installation process as I bring you along with me, installing all of this equipment. For now, I need to go to the drawing board, come up with a schematic, plumbing design that's going to incorporate all the bits and pieces that I'm going to need, figure out where each different component's going to go, and then we start the installation process. Where do you start the installation process, you might be wondering? Well, let's touch on that next. Okay, here we are back, and that's a little less complicated. So it's often the question that people have when it comes to installing pool equipment. Where do you start? You know, it's kind of a lot going on here, and it can be confusing, especially if you're not a plumber and if you don't work with this stuff all the time. So I usually tell people, start at the pump intake. The pump placement is very important here, and that's why I kind of give it priority, and it also gives me a starting point. Normally at the equipment pad, you've got a bunch of suction lines and you've got a bunch of return lines. So I kind of collect all the suction lines together, bring them into a manifold, run them into the suction side of the pumps, and then from there I can start building the system. And the order that I would go in would be pump, filter, heater, peripheral devices, chlorinator, and then the return lines back to the pool. Now, I mean, this is just one example. You could change the orientation of the pumps to this way or that way. It's kind of dependent on every single system. This particular system that we're looking at here is going to be a shared pool and spa system, and that's the row of equipment that you see at the back here. That's your filtration and heating for the pool and the spa. And then this pump and this filter here are going to provide us some peripheral flow for water features, massage jets, that kind of thing. So your system might be different. It might only have one pump. It could have 7 or 10 pumps. Believe me, there are a lot of those pools out there. So the average pool, I mean every pool, it's going to have one pump, one filter. If you're lucky, it'll have a heater. Probably some sort of chlorinator like an erosion feeder or a salt cell for a salt chlorine generator. And then the water, of course, diffuses back to the pool through the return lines. By setting the equipment out like this, before we begin the process of plumbing, it allows you to kind of play a little game here where you turn things around and you measure with your tape measure and you kind of determine, like, I'll give you an example here. This particular filter is offset from this pump, where this filter is in line with the pump. They're different filters. They have different positionings for the intake and the discharge from the filter. So you really have to do stuff like get in here and put it like that. No, it's too close. Okay, turn it. I could put it this way, but then the discharge is on the wrong side. So that's kind of the game you play when you're installing pool equipment. Get it all out of the boxes, get it into the area that you're working with, grab a tape measure, and just start kind of laying it out. Pump, filter, heater, peripheral devices, chlorinator, and then your return manifold back to the pool. Here's a tip I have for you. If you were to be installing pool equipment for the first time and you're kind of following along and maybe you're going to try something like this for yourself, don't leave extra space in the pipe. Sometimes there's minimum amounts you need. Specifically on the suction intake of the pipe, you want at minimum 5 times the pipe diameter in a straight run into the pump. So that's no valves, no 90s, anything like that for a straight run. 2-inch pipe times 5 would be 10 inches of straight run into the pump. So aside from that one particular measurement that you need to observe for installation, you pretty much want to build the equipment in as tight as possible whilst still being able to access it at all sides for service. Even, for example, you can see I've got these 2 filters placed pretty close together. My only requirement is I want to be able to fit between them. If I can do so, then I'm happy with that. So that's kind of the way that I go about placing the equipment, is you get it all spread out into the area that you want, start at the suction intake, observe the 5 times the pipe diameter minimum as a straight run into your pumps. But then from that point forward, like if I had the option to have this filter here, but if I wanted to, I mean, I could also just put it over there. What's the difference, right? Well, pool equipment can get pretty complicated. Some of these equipment pads are pretty complex, and if you left extra space in between everything, by the time you get done, it's going to be like, you know, half a golf course away for you to go and turn some valves on the return manifold. So observe that suction side spacing, but otherwise, I like to make the equipment basically as tight as I can. I wouldn't want it touching the pump. Now I can't service or access this pump. It would be inconvenient to access the electrical compartment, and that's certainly something that you can't and shouldn't do, which would be to restrict access to electrical compartments. So I would want a little bit of room. I want the pump to be able to breathe. I want to be able to access the keypad. I want to be able to access the electrical connections. I want to be able to walk through such that I could service the equipment, make changes, install it, do all the different things that you need to do. And when you're installing, I want you to think in the mindset of longevity. We're going to install this equipment one time. You are going to interact and look at this equipment every day for the rest of your lives. If there's a pipe on a funny angle, fix it, make it straight. Everything should be plumb, square. Don't do anything that looks bad. Take the extra time to make it look good, because again, we're only installing it once. That's only a small inconvenience one time. Every day for the rest of your life, when you're out on your pool patio drinking your coffee, you're going to notice that pipe that you didn't install properly, and it's going to bother you. Or at least it's going to bother me. So let's just do it properly the first time, and you're going to be happy with the results. I'm going to be happy with the results. Everybody wins. Not to set like a bar too high for myself or anything. It's got to be perfect. Once I know all of the equipment is going to fit in the space that I have provided, and I have a general idea about the placement and orientation for each of those pieces of equipment, now I'll kind of pull all of the equipment away except for the pumps, leaving the pumps, and I'll start to work on the suction intake for the pumps. Once the suction intake is built and connected to the pump, that kind of like stabilizes the whole system, because now that's kind of solidly placed and you can build off of that and everything's not kind of flopping and moving all over the place. So it gives us a nice solid point at which to start installing this pool equipment. Throughout the process of installing this equipment, there are going to be a lot of steps involved, and I'm going to do everything I can to take you along with me throughout the process and show you all of the parts and pieces so you see them for yourself. It's going to take many hours to install a system like this, and that's just the rough installation. Then there's the finishing details and the programming and getting it all up and running and calibrated and stuff. It's a lot of stuff, so I'm going to do my best to show you all of those details. I know you want to see them, but I want to respect your time, and I'm going to try to consolidate it down where I give you the maximum amount of information in the minimum amount of time. So let's get started. Coffee break. Then we get started. Okay, time for a little honesty here, folks. It's been probably 20 years since I installed a full suite pool and spa automation system, multiple pumps, peripheral items, automation, digital programming, motorized valves, the whole bit. I definitely know this stuff, but it's been a long time. And I'm really looking forward to doing this because I think I'm going to be learning along with you as we install this. And that's important because it's going to give me access to organic questions as they come up. That likely the same questions that you're going to have should you be installing one of these systems for yourself or wanting to know more about these systems, how they work, how they get installed, what do they do, and how do you make it do that? So I hope you'll be kind and forgiving in the comments of the YouTube section, which is not something that you really ever expect from comments from the YouTube section. But strangely, my Swimming Pool Steve YouTube channel attracts primarily really positive comments from people, and I really appreciate that, guys. I think that's uniquely uncommon on YouTube and something that I definitely enjoy. So with that being said, let's go ahead and get started with this installation. I'm going to bring you with me the whole time. Hopefully I don't make a bunch of really embarrassing mistakes that I have to then reveal to you and you can all laugh at me, ha 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 ha. But then we'll fix it and then we'll really get it going. I mean, hopefully we get it right the first time. That's what we're aiming for, but it's been a long time for me. These are intensely complex systems. This is essentially one of the most complex systems that you could get for a residential swimming pool, short of, let's say an infinity edge system, which is definitely more complex than this. But this has a little bit of everything. It's got a hot tub, it's got a swimming pool, water features, it's got massage jets, multiple pumps, multiple filters, full suite automation, a salt chlorinator. This is going to be a good one. Stick around, folks. Okay, here we are back. We got the rest of the equipment out of the way. Where do we start with this installation? We start with the pumps. And this is something that, I guess it's dealer's choice. There's probably other professionals who do it a totally different way. I like to start with the suction intake, kind of get that built, get the pump permanently attached into some plumbing so it's not moving around all loosey-goosey. And now I have a more stable platform from which to start building chronologically. So I start at the suction intake, I go into the pump, pump to filter, filter to heater, AOP, chlorinator, whatever you have after the filter. It all goes into there. Once that's done, then the water goes back to the pool. And that's the same order in which I like to plumb things. So this kind of brings up a new point here, which is dry fitting of plumbing fittings versus just starting to glue stuff together right away. Most of my career is just gluing stuff together right away. And I suppose once you reach 10,000 hours of doing solvent welding PVC, it's a lot easier to just kind of eyeball things and start going. But this is a game of inches. When you're cutting and fitting these things together, some of the lengths of pipe and things like that, they're not going to really have a big impact on how this product looks as a finished version. But some of them are going to matter a lot. Like the difference between a 1/4 inch too long or a 1/4 inch too short on a piece of pipe that you cut means that now this new piece that you're installing, it's no longer level, or it doesn't meet up where it's supposed to meet up cleanly. They're kind of meeting on an angle and you have to stress it to get it in. That's not ideal. You don't want that. You don't want stress on solvent welding fittings. You want everything sitting natural. You want no stress. You want well supported, because remember, once these pipes are full of water, they're a lot heavier, and in addition to that, you're going to have pipe hammer and vibrations and shaking and all kinds of stuff. So you definitely want to go out of your way to make sure that you're installing the stuff in such a way that it's not stressed out. You're not going to break the pipe or the fittings. It's not going to vibrate and shake around like crazy, which ultimately could lead to other leaks or failures. So you just want to avoid all of that stuff. So dry fitting versus just solvent welding right away. I think the best answer for most people who are approaching an equipment installation would just be to maybe combine the two. Let's do some dry fitting of pipe up until we reach a point where that 1/4 inch matters, right? I can do some stuff on the intake of this pump because we have some hard numbers to work with. And what do I mean by hard numbers? Well, I'm going to be using 2.5 inch pipe for this this pump right here, for the filtration pump. And I need to have 5 times the pipe diameter in a straight run in front of the pump. And that is my first cut of pipe, because I know I need 12.5 inches of my 2.5 inch PVC pipe on the suction intake of my filtration pump. So let's go get that and we'll get started there. Ta-da, here we are, 12.5 inches, square cut, beveled ends, 2.5 inch PVC. And for now, I'm just gonna dry fit it in place. Uh-oh, What's going on? Why won't this fit? Well, this pump is made for 2-inch slip ports or 2.5-inch spigot ports. Let me show you what I mean here. Here I have a 2.5-inch coupling. So the 2.5-inch pipe goes right in there. Now I take that 2.5-inch coupling, and that's what I'm going to solvent weld to the intake of this pump. So again, I'm not starting yet with solvent welding. I've just dry fit some pieces in there, and notably, I didn't force or bury that pipe in there. Just kind of wiggle it snugly, maybe turn it, but don't force it too much because it's going to bind and you're going to have a difficult time pulling everything apart. Before I moved these pumps, I've marked them on the floor, so I have a good idea where I want them. But for now, I'm just going to work with the filtration pump, so I'm going to go ahead and get the booster pump out of the way, and we'll deal with that at a later time. I'm going to point out something this is just like a finicky detail, but to the pool plumbers out there, they'll appreciate the difference here. So I've got this pipe, right, and I'm going to glue it in. I'm not going to glue it like that because I don't like seeing the lettering on top. I mean, it doesn't hurt a thing, right? You could even take a sharp knife and kind of scrape that, and you'll be able to peel that coloring right off of there, and you won't be able to tell it's there. But that's not my preferred method. When I do something like this, I'm going to go out of my way to install all of the pipes like this. Maybe it doesn't work for each and every one because there's going to be a lot of pipes and a lot of connections here, but to whatever extent I can to improve the cosmetic value of this installation from the finished perspective, I'm going to take that little bit of extra effort here, and it's going to pay dividends. We're only installing this once. You're going to be looking at it and interacting with it for decades. Here I have a Jandy 4719T diverter valve. So this is a 2.5-inch slip port, 3-inch spigot ports. These are very large valves, and I'm using these because I want good flow dynamics for this system. There's going to be a lot of flow here. I want flow efficiency, but I also am going to be adding automation to this system. With a ball valve, for example, you can't add automation to that. All this assembly here is what you need to have if you want to attach a motorized valve actuator onto this, which will then control the function of the valve for you automatically with your automation system for your pool and spa. That's why we're using these, and that's what comes next. Now they're pretty heavy, and again, I don't want to stress anything out here. I'm not going to be going too much further here before I actually start to glue things together, but maybe just a couple more steps. Okay, here I have a couple of pieces of short PVC pipe and a couple of 90s. I'm going to come out of that T with the short pieces, and then I'm going to 90 upwards. That's the direction of travel for where my suction is. This is a flooded intake system where the pump is below the water level of the swimming pool versus a lot of swimming pools these days, and traditionally speaking, the pump is located above the water level. So you would be coming out, instead of traveling upwards with your pipes, you would be traveling down into the ground where your pipe runs are located. So let's talk about making these connections here, and I want to point out a couple of important things about solvent welding PVC. So first of all, I've got a couple of pieces of pipe here. Take a look at them. How do they look? Are we ready to get started? Do they look good to you? They don't look good to me. So first things first. I'm just going to take off some of this fluff. And for a lot of people, they'd be done right here. That's it. Go ahead. We can solvent weld this into place. And it's probably going to be fine if you do it. But it's not as good as it could be. So there's two things I want to point out here. Number one, you need square cuts. And how can you tell if you have a square cut? Actually, the pipe is actually more level than my floor there, notably. So as long as you can stand the pipe up and it's standing up and it doesn't just refuse because it's on a 30-degree angle, you're probably okay, but you do want a true square cut. Now here's the thing. Beveling this pipe. This pipe is a sharp edge. Like you saw me run my finger around there. If you do that without gloves and you have soft, city slicker hands, you're going to end up with cuts on your fingers because this PVC pipe is sharp. So here's what happens. We go to start solvent welding. I primer, I put the solvent cement on, I insert the PVC into the fitting, but this sharp edge, like almost razor sharp sometimes, as you're pushing it in, it cleaves or cleans the solvent cement from the outside of the fitting. That sharp edge is like a knife scraping it away, and then you end up with almost no solvent cement joining the connection. That's not ideal at all. Now, an experienced PVC plumber would know, well, the trick around that is you don't push the pipe in. You really don't ever do that. You push as you rotate. And when you do that, it's a different world entirely. You'll be able to bury the fitting, no problem at all. But that sharp edge can still be a problem. So I wanted to show you a tool that I bought off of Amazon, and it was really inexpensive. They actually make a ton of different tools for beveling edges, and there's a lot of money. So this one here is not a lot of money. I think I paid 10 bucks for this. Check it out. So it's like a little rotating razor blade, essentially. And I honestly was a little skeptical if this was going to work, but take a look here. I'll show you. This one looks pretty bad. Okay, so here we are with our sharp edge. Hopefully you can see this. Do be careful. This is a razor on a stick. And you just kind of carve the inside edge. And you can see it does a really good job, actually. I was not expecting this to be as functional as it is. And it's kind of neat because it actually bevels both the inside and outside. Okay, so that inside's pretty good right now. So outside. It's my second time using this, so I'm not very proficient with it. Also, I'm holding up to the camera. You know what I'm talking about. I'm going to hold it down here so I don't cut my fingers off. Okay, there we go. So yes, it's slow. Yes, I will get faster at using it, but it's highly effective. And for $10 versus some of the other options were like 80, 100 bucks. If you're doing these all the time, for sure you get the expensive one. If you're doing a one-off, I bet you this is the better tool. It also comes with like 10 extra blades too, so no worries there. You'll definitely have enough to go around to get your installation done. I think you can see where I'm going here. So it's about the time where I'm going to start solvent welding things together here. I don't really want to go too much further without being able to actually get my true finished measurements here. I'm going to point out one thing though, because once I put the mask on, which you definitely should be wearing when you're solvent welding PVC, it's a little bit harder and more uncomfortable to talk. So I'm just going to try to get through the work once I've got the mask on. But I wanted to point something out here. Okay, so I'm going to get to that situation where I need this and I need that. So what order should I do that in? Well, I'm going to start here and there, but if I go here next, you can do it. Like, I mean, you actually can do this a lot of different ways, but you will make your life easier if you do stuff like this. So I've got this piece. It's going to have to be glued into here. I can do it while I'm crouched down there on the ground, no problem. But anything that you can kind of pre-build, well, go ahead and do so. So for example, right here, I'm going to have that, but then I'm going to have an upright into some valves. Well, why don't I go ahead and get that other piece ready as well? And then I've got the valve and this, and so I'll glue both of the pieces into this 90, and now it's ready to go. Then I make this connection. I can set my level so that it's perfectly plumb. You need plumb and square and level when you're installing PVC. Any mistakes you make in that regard compound as you're doing this. And what starts with a slightly out of level pipe or something that's not quite in the right spot, by the end of the job, it's gone sideways on you. So you really need to pay attention to the details when you're doing stuff like this. But I think we're just about at the point where we're going to start solvent welding these pipes together. One more thing before I put the mask on, because I want to have a chance to talk about it here. So we're going to be solvent welding PVC. I'm going to be using Weld-On products for solvent welding. They make a host of different products, and there's actually like a number of different ones you could use. I'll give you an example. So P68 primer, stuff I've been using for decades installing swimming pool equipment, but now they make a pool primer. I mean, I'm not a scientist. I did look up the ingredients in it. There's minute differences between this product and this product. Which one's right for you? Well, they went ahead and they made a product especially for me. I'm a pool plumber. That's all I plumb. I don't plumb houses or toilets or any good stuff like that. just swimming pool stuff. So when a manufacturer comes to the table and they develop a product specifically for me, that's the product I'm going to start using. So in that sense, we've talked about the pool primer. Let's talk about the solvent cement, because holy smokes, there is a lot of them out there. Like, again, this is kind of dealer's choice. I'm going to show you what I like to use. You could approach things differently and probably experience success still. So I like 705 clear. When I'm dealing with a mechanical room installation, I like that it's clear. I don't want to be able to see glue joints and drips and all this kind of stuff. And if you're skilled enough, there shouldn't be anyway. But just as a point of habit, this is what I got used to using when I install pool equipment. Is it the only choice? Is it the best choice? I don't even think it's either of those things, but it's what I'm used to using. Let's talk about some of these pool-specific products. I mean, I just mentioned that, right? They make products for us now. Let's use them. Wet or dry. Wet or dry is probably the first pool specialty product that I see that came out, or I saw come out for solvent welding PVC pipes. It's blue, notably, because pools are blue. This stuff here has a tiny concentration of methyl ethyl ketone in it, where a lot of the solvent cements do not have that. I believe that is the addition that they've added to help combat this wet or dry situation, because MEK evaporates readily, and it also softens plastic very aggressively. So the combination of those two things allow us to use something in slightly damp environments. Wet or dry does not mean like standing knee deep in water and pouring rain, or trying to solvent weld a connection with actively running water. It means to deal with some residual moisture or dampness only. But it's a great product and it sets extremely fast. And along those lines, that's kind of like what Weld-On went with when they developed the pool and spa line. Specifically, almost all of the different, and they offer a lot of them, like 746 pool heavy, 747 pool or spa. All of these are extremely fast setting solvent cement. That means you solvent cement the connection, you hold it, you count to like 1, 2, 3, you let go. Pretty much it's how it is. It's setting up super fast. And further to that, the amount of time for low pressure pressurization is very low, much lower than a lot of the other solvent cements. And why would that be? Because us pool professionals are so busy in the summer. We don't have time. I don't have 24 hours to leave. Your pool could turn green if it took me 24 hours for the solvent cement to set up to the extent that it could pressurize your system again. We don't have time for that. So they've developed a line of products that are extremely fast setting, and they cure very, very quickly. And they're blue. I like that. So the 746 pool heavy I want to talk about. I used to use the heavy-bodied solvent cements almost exclusively. Like, why would I use a regular body or a medium body when there's a heavy body? Heavy must be better. I want good connections for my pipes, and that's what I used. But you know what? It wasn't the right choice. Again, products for specific applications. The heavy-bodied stuff is for really large pipes. Like, I think 8-inch or 12-inch minimum is what you would start using this product for. Anything up to and including 4-inch pipe size, which is pretty much everything in the pool and spa industry, is well covered by the regular bodied solvent cement. 747 medium bodied blue, extremely fast setting. Again, another pool and spa specific product. And which one's right for you? Well, it depends on where you're located, because some of these products, like they contain chemicals that maybe you can't use in California or something like that. So there could be ones that aren't available in your area, and that's why there's other ones that are similar that are more widely used in other areas. Which one's right for you? Well, 705 clear for me is great. I've always liked 711 gray. That's kind of like the first one that I ever started working with. 725 wet or dry when I'm in the trenches or plumbing if there's any kind of moisture. I like that. 746 is if you get into the big stuff, like maybe I'm not alone. I've done pool plumbing 12 inches and larger for some really fantastic installations. That's when you crack out the heavy guns there. And then the pool or spa 747. I'm pretty sure that it doesn't contain methyl ethyl ketone. I can't remember. I did a bunch of research into all of these as to the chemical constituents, just to kind of determine what are the difference is between all these. Like I didn't really know. I still am not totally proficient on this, but I do know that I want to use the pool and spa specific products wherever possible, because this is above my pay grade. If a scientist comes to me and says, I made this product for you, it's going to work better for the stuff that you do, that's good enough for me. Let's use it. So for this installation, I'm going to jump in and get started with the 705 clear. It's the one I like. It's the one I'm used to. I'm going to use the pool primer. And I want to show you one more thing, actually. It's really important. Okay, so how do you open this can? Well, you could be strong like a gorilla. That might work. It doesn't work for me, but it might work for you. Channel locks. Don't do this yet. I'm going somewhere with this. So I know if I grab the lid with the channel locks, I'm going to mar it up. It's going to fail to seal. If I'm expecting any longevity of the can, I'm probably not going to get it because there's going to be moisture intrusion into the can from humidity. So one of the things I used to do is I would take, the handle of my channel locks and just try to create some leverage with it and get it open like that. It works sometimes. In a pinch, and I know I'm not the only person who's done this, you take the can and you just bash it on the ground. If you hit it on an angle, now you cave in this lid, but if you manage to hit it square on top, you can kind of dent it ever so slightly, but you almost certainly break that seal on it, which allows you to open it. All of these things are the things which I used to do. Now I use the Weld-On Easy Twist can opener. That's this product right here. This is part number 14550. So Weld-On 14550 fits on, and Bob's your uncle, just like that. And more importantly, unlike the channel locks, you're not marring and damaging the lid here. And if you work with this stuff regularly, I highly recommend picking up one of these. It's certainly worth it.
Okay, so let's get started here. Anytime that you're solvent welding, cement, primer, any stuff like that, protect the equipment. This equipment is extremely expensive. You do not want to ruin it because you've got glue and primer all over it. So as we get started here, I actually decided I'm going to try the 747 first. I haven't used this one, so I just want to try it out.
Something I do consistently throughout this installation video when I am solvent welding, when I apply the primer and then the solvent cement, I almost always do the slip connection. So that's the one I'm doing here, the coupling, and not the spigot connection, which is the pipe itself. The reason I do this is just simply because as you apply primer and glue, you're going to get a couple of drips. And if you apply it to the socket first, you can kind of use the socket just to hold the glue in place or the primer in place. The spigot, you can't hold anything. It just drips off readily. So that's why I always, lean towards doing the one first versus the other. And you'll see me do that consistently throughout this video. If you're wondering why I've used a different can for the primer here, the reason is simply that when you apply primer to CPVC, which is what that pump union is made from, that black wipes off readily and it leaves just a black stain on my primer. And after a while, my primer will no longer be clear. It will be kind of like a gray color. And so that's why I use a specific can for any CPVC connections throughout this video, and this larger can here for just doing the regular PVC priming.
Extremely important if you're working with any kind of valving. You would never want to have it such that the glue and primer run into it. And in fact, I believe by the book, I should actually be removing the guts from the diverter valves. But if you're very careful with what you're doing and you're conscious of the orientation of the glue and the primer, then you can do this without damaging the valves.
So let's talk about suction manifolds for a minute here. And for example, this valve I'm working on is a very large valve, and you might be wondering why I've used that. It's simply because I don't want to create a choke point. Choke points are a problem with a plumbing system, and especially on the manifold side, which is kind of what we're doing here. We're building a suction side manifold, which is to say we're going to have multiple pipes all converging into one trunk line. In this case, the trunk line is going to be 2.5-inch PVC, 2.5-inch PVC. It's kind of a little bit larger than average, and it is that way because we want good flow efficiency. That's how you get good flow efficiency with a swimming pool, is larger plumbing. It's important that we keep the 2.5-inch trunk line free of obstruction, so that's why we've got this larger than average diverter valve that we're using here on the suction side. If it were only going to be 2-inch plumbing, I'd probably use a smaller valve here, but because we have the larger plumbing, we use the larger valves. The suction side in particular is very important in terms of flow velocity. You don't want to lose efficiency in your plumbing system, and you do lose efficiency to fast moving water. Fast moving water has a lot of friction and a lot of turbulence, so we want slow moving water. How do you get slow moving water? Well, you simply have a larger pipe diameter. So the entire system would benefit from larger pipe diameter, but if there was one spot in particular that benefits the most, it's the suction side plumbing. Unistrut or U-channel is the galvanized steel hardware that you see me working with here. It's commonly used for electrical contracting and commercial applications for running EMT or electromechanical tubing, but it also works very well for PVC pipes and holding everything perfectly in place. As long as you're not too forceful with those clamps, making connections that are too tight on the plastic pipes, because of course the U-channel and Unistrut is primarily meant for steel and stuff a lot stronger than PVC. So you have to be careful when using it, but U-channel or Unistrut is a fantastic tip for people who want a clean installation for their pool equipment. So what we're looking at here is, on the left we would have the hot tub suction, and on the right we would have the swimming pool suction. So we would call that like the swimming pool skimmer line is the one on the right, and when we're operating in pool mode, that's going to be where all of the water is drawing from. When we're operating in spa mode, the valve is going to turn and all the water is going to be coming through the left-hand pipe there. And that's what a swimming pool and spa shared system looks like, is you'll have swimming pool suction on one side, it could be one pipe or multiple pipes, and then you'll have spa suction on the other side, usually just one pipe for a spa suction.
Perfect.
$45.50. So right here, I'm working on what would be the equivalent of your actual swimming pool or your actual hot tub. So I'm using a test tank here as opposed to a physical swimming pool in order to facilitate this installation. But the pipes that you see me installing now would represent the actual swimming pool and the actual hot tub itself. Now, it's important to remember here, I have made literally tens of thousands of solvent welded connections, which have gone on to be proven in the test of time. So I'm probably making this look a little cleaner and a little easier than what you might make it look. And if you make it look this clean and this easy as well, then congratulations, because it's looking pretty good for you. You'd probably be able to get a job at your local swimming pool company, or maybe you already work for one. For the average person who doesn't do a lot of this stuff, it's going to be a little bit tough to keep this looking as clean and as neat as this. But I encourage you to try. The more effort that you take to try to keep things looking clean and neat, wiping the pipes, using towels to protect everything, that's what you want for an installation like this.
That's a pretty good start. Let's take 5. I'll see you back here in a minute.
Well, here we are back after an extended break for me to take it easy and let some glue fumes clear a little bit. I want to talk about what we're doing, then I'll mask up again and keep going with the solvent welded connections. So for now, there's a couple of challenges which I encountered that I want to share with you, and I want to share with you the options that I considered taking and then the option which I did choose. So here's the thing. If I were using 2-inch plumbing, no problem at all. We've got enough room to make this connection here from pump to filter. If we were to use 2.5-inch plumbing like I'm using, there's a little bit of a problem, because by the time I get my coupling on the outside and then a short radius 90, I'm just a little bit too high, about 1 inch too high for the intake on the top side of the filter here. So one option, I could do a double 45. So I 90 towards the filter, and then I have a 45 kind of aiming downwards-ish, usually down to the side, because I only need 1 inch, not more than that. And then another 45 to bring the pipe horizontal again. And it's not going to be great, and it's not ideal. I mean, if you don't have to use fittings, I don't want to use them. It's money, it's more flow restriction. So what other options do we have here? Well, here's a really great option, actually. I could put the filter on a housekeeping pad. And a housekeeping pad is relatively uncommon on residential pools and extremely common on commercial pools. Basically, it just means that we're going to pour a small pad of cement or a small pad of concrete underneath of the filter, such that the filter is a few inches higher off of the ground. Primarily, the function of a housekeeping pad is housekeeping. It allows you to clean, sweep around the equipment. It also allows the equipment to be raised above the floor level such that it wouldn't be affected by water or anything like that. Commercially speaking, you would find them pumps, filters, heaters, everything kind of gets put on the housekeeping pads. That was an option. I could have stopped. I could have poured a small concrete pad to raise up the filter, or potentially even used a large patio stone or something to this degree. I didn't feel like doing that. I felt like showing you that you can heat bend PVC. It's not something that you see a lot, but you can totally do it. And as long as you do not scorch the pipe, you actually don't damage it at all. Once it's cooled down, it's as strong as it once was before you did the heat treatment to it. So long as you're careful and you apply heat evenly. I mean, there's a couple of ways that you can do stuff like this. You see people using a tiger torch, which is a propane powered handheld flamethrower, and that's not ideal. I do not like to use open flame, and I find that you pretty much automatically scorch the pipe doing that. Consistent, even heating, the creme de la creme for heat bending pipe. We call them the Betty Crocker oven, but it's a Greenlee is the tool that I'm most familiar with, and it's just a 2-foot long oven, and you rotate your pipe in there, and there's some heating elements similar to what you have in your oven, and it heats the pipe up evenly as you rotate it. It works great for if you do a lot of custom work. This is not a lot of custom work. This is just one little piece from here to there, nor do I have a Greenlee pipe oven. So I used a heat gun, just a regular old heat gun, not even an expensive one, and just apply that even heat. Take your time. Patience is key if you're heat bending pipe. And what I'm bending here is an offset, right? That's what the double 45 was going to accomplish. That maneuver is called an offset. And so I've made an offset with 2.5-inch PVC pipe, which is maybe not the easiest thing to do. This is not the very first heat bend that you ever want to make. You probably want to start with 1.5-inch plumbing. It sure is a lot easier. 2-inch even. By the time you're at 2.5-inch plumbing, this stuff's pretty big and it's pretty hard to heat it up evenly. When I use a heat gun, I'm careful, I take my time, I don't try to rush it. If you take your time and don't try to rush it, you don't even need one of the infrared temperature guns. I have one of those. It makes it a lot easier. As you approach 170 degrees Fahrenheit, the pipe begins to soften between 180 and 190. It's relatively malleable at that point. Bending an offset, you have to heat a larger area because you're kind of doing both of them at the same time, because you don't want to do what's called a dog leg, which is where you have the pipe bent, but we no longer return to the horizontal plane. We're kind of kicking off into space somewhere. That's not what we want. So this is just an example of something that you can do. Totally fine to do so. Take your time doing it, and you can do so with something as simple as a heat gun. You know, as I was heating this pipe up here, it occurred to me I haven't really done that kind of work for a while, and this is, not the hardest maneuver to make here. It's just an offset with 2.5-inch PVC over a relatively short distance. It posed a 6 out of 10 on the difficulty scale. I'm going to try something a little more challenging later on. I think it should be fun. I hope it works, because now I've told you I'm going to do it, so I'll probably show you whether it works out for me or not. I hope that I can make it work out. More on that later. Let's get back to the installation. I've got my offset pipe. I know I have the clearance that I need to achieve the inlet height. I think we're pretty much ready to get started. I went ahead and pre-cut just a couple little bits and pieces to get me started so that I can kind of make this process move along a little faster once I mask up, because it's hot as heck in here and pretty uncomfortable. Anybody who's worn one of those half masks can tell you it gets pretty warm after a while. But I think that, oh, one more thing. I want to mention one more thing before I got the mask on. So here's something I'm going to do. I'm going to use some of this CPVC solvent cement. I technically don't need to be doing this, but I'm doing it to illustrate a point. So if we were to have a problem with heat causing some sort of failure of the PVC system, where would that happen? In our hypothetical world where everything went wrong, where is the heat being generated? Well, one of the biggest culprits would be this connection right here. The motor itself, there's friction and moving parts and a lot of power consumed and output. So if I were to have a problem, that's where I'd have it. Do I think I'm going to have a problem? I definitely do not. Using these large CPVC unions that Hayward uses for their equipment is actually fantastic. It all but alleviates this concern, but I'm going to use it anyway because I have it. And the truth is that this stuff doesn't last forever. It goes bad after a while, and I don't do a ton of CPVC connections anymore. So I have some and I'm going to use it because in my test lab here, I like to illustrate points, and this is going to be a visual illustration. I'm going to use the CPVC solvent cement everywhere throughout the system where I'm concerned with a heat-related problem. So one more thing I'm going to do here before I get started. I'm going to have a pipe coming up and out of this, and it's going to cover up this keypad here. So I'm going to go ahead and rotate that keypad just to make it such that it'll be a little bit easier for me to interface with it. Now, I plan to actually automate this, so I'm not really going to be interfacing with it, but I'm still going to rotate it because it's easier to do so now. So let's do that. So what I'm installing here is the trunk line. This is the singular pipe which is connecting from the pump to the filter and the filter to the heater, etc., moving on down the line. I'm installing it now before I put the filter in place just because it's easier to get to. But it's important to note that it is a large diameter. This trunk line represents the main point of flow efficiency through your system. Most pools have 1.5" or 2" as their trunk line. This system is using 2.5" pipe throughout the filtration system. I must admit I was a little concerned about gluing the coupling on over top here. Was I going to ruin the functionality of this union? And the answer was no. The union still had enough free range in order to spin, remove, and reattach once this installation was completed. If you were following along and installing your system at home just like this, this is a point where you need to stop and you need to do your system differently. The way that I'm installing mine directly with a hard plumb connection from pump to filter is not how I would do this for an outdoor swimming pool. I'm doing that exclusively because it suits my needs for my test lab installation here. Right there, you should have, instead of a 90, you should have a 3-way diverter valve installed here. And the reason you should have it is it allows you to pump from the pool directly to waste, like a hard plumb waste line or a lay flat roll up discharge hose that you roll out anytime that you get a lot of rain and you want to lower the water level in the pool, or you want to do a lot of vacuuming with a heavy debris load, but you don't necessarily want to load up your cartridge filter. You want to be able to pump that to waste. Well, if you had a 3-way diverter valve at this connection here, you'd be able to do that. And for your outdoor swimming pool installation, I recommend that you do that. So we've gone into the filter, now we're coming out of the filter, and then just continuing on down the line with the main trunk line for the filtration of the swimming pool. It's going good so far. The next step here is going to be to build a heater bypass, because I don't want the water to go in and out of the heater always. I want the option to be able to have the water go through the heater or not. And there's a couple of different configurations that you can build a plumbing bypass with. I'm going to go over one really popular one with you in just a second. So, how to build a plumbing bypass? There's so many ways. This one is going to be done with a single 3-way diverter valve and a single check valve. there's 2 zone bypasses, 3 zone bypasses. Zones are the valves. That's the control. So this really is just a 1 zone bypass plus a check valve. It's one of the most efficient and cost-effective ways to zone in a pool heater. So basically, this is what we're going to be going after here. This is going to be the return line from the heater. The bottom one, exiting stage right, is going to be the cold water supply to the heater. The T, which is in my hand, is the bypass. When the heater's on, then I would use the diverter valve to allow water out the bottom, which would go to the heater, and then it would travel through this one-way check valve flapper here en route back to the trunk line for the filtration system. But if I don't want the heater on, I can close and isolate the bottom port with the diverter valve. Water traveling up through the trunk line here is not able to go this way because of the check valve. So that's why we use this configuration. So there's a bunch more connections here to make, and then we're going to start building it up the wall here. Let's just go ahead and get started. This heater bypass installation that I'm installing now is probably confusing to the eye, to the non-plumbers following along with this installation. You could just imagine a 90 right now instead of that 3-way diverter valve I'm installing. And the 90 faces up, and that's our trunk line. And you just pretend we don't have a heater. But in this case, we do have a heater, and it's just on the other side of that blue curtain, exit stage right. And so that's what I'm installing now. I'm installing the bottom line, which is going to be the cold water supply to the heater. And then I'm going to have the top line returning through the check valve back into the trunk line with the hot water return from the heater. Here's something I would do different. This installation is being done on a shop floor where it really doesn't matter at all. You can just go ahead and use and abuse this floor. You couldn't hurt it or stain it any worse than it already is. But let's assume that this wasn't, a floor that I cared about. I would definitely put down some cardboard, because in the finished product, you can see there's quite a lot of purple primer and blue solvent cement staining on the floor right in this area that I'm working in now. So that would be something I would do different. While it is common to have pool heaters which are installed directly adjacent to the pump and the filter and the rest of the equipment, oftentimes there's a requirement or an advantage to remotely locating a pool heater. In my situation, I want the pool heater installed outside, not inside of my shop. I want to use a very large gas-fired pool heater. And as a result of the venting requirements, it was just easier for me to pop the pipes out stage right here and then continue them on outside to the gas heater versus having them installed, or having the heater installed directly in my shop. It's also worth noting that if you have an electric heat pump and not a gas-fired heater, there's often an advantage for you to locate that heater where it's going to get the absolute most amount of direct sun, because that's going to improve the performance of your heat pump drastically. And it's also going to sweat up to 5 gallons of water, 5 gallons of condensation per hour at times. So you need to install a heat pump somewhere where it's got a tremendous amount of drainage provision. I mentioned that there are different kinds of bypasses that you can build, and we built one already with a 3-way diverter valve plus the check valve. Now I'm going to build a different type of valve bypass. This one's called a 3-zone bypass. And as I mentioned before, zones are valves, so basically there's just going to be 3 valves creating a configuration where I can have all of the flow bypassing, none of the flow bypassing, or some of the flow bypassing. And in this case, when I'm saying bypassing, I'm talking about the HydraPure AOP system that we're going to be installing in this location. The reason I need a 3-zone bypass here is that my trunk line flow rate could be so high that the peripheral equipment I'm installing, in this case an AOP system, a Hayward HydraPure hydroxyl radical generator, the maximum flow rate that that piece of equipment is designed to take is lower than what my system might be able to generate. So that reason means that I must locate that piece of peripheral equipment on an external bypass off of the trunk line. I can't have it on the trunk line because it could be damaged by the amount of flow that my system generates. Now, you also could say there's reasons why you might elect to or want to locate a piece of peripheral equipment on a bypass like this 3-zone bypass that I'm building now, such that you can regulate the amount of flow to something or potentially turn things off completely and still operate the system. It's really important with a 3-way diverter valve that you observe the embossed lettering which says Inlet. Inlet refers to the direction of the flow of water, and you should always point inlet towards the pump. So the water is coming from the pump, so point inlet towards the pump when you install a diverter valve. You can actually remove all of the screws and change the internals around such that you change the inlet orientation. Just make sure that you understand that every diverter valve has that. It's very small and you might miss it if you weren't looking closely, but you should always observe the inlet and flow of water, and this prevents deadheading of the pump. If you have the inlet set in the correct location, it's impossible for an untrained user of the system to accidentally deadhead the pump just by turning the valve handle in the wrong direction. That's what observing this inlet embossed direction flow of water ultimately does. It's just a safety and prevention measure to prevent against deadheading of the pool pump. Well, despite the mask, I guess the glue fumes are starting to get to me because I'm about to make a mistake in this system that I'm going to realize at a future point and have to make some changes. So let's just all go ahead and enjoy the moment and watch me making mistakes. Oh, that mistake that I'm making there, that's not even the mistake I'm talking about. So I guess it's actually 2 mistakes. Continue enjoying the montage of mistakes by Swimming Pool Steve, which surely we won't have to touch on later. It is the act of gluing this T in that I'm going to have to revisit later, because the T does not facilitate automation. And this is the point at which I require a valve, and the valve to be able to be automated such that I can divert the flow to the left to the hot tub or to the right to the swimming pool. Similar to the suction side of the system, where we built a suction manifold where we had the spa suction on the left-hand side and we had the pool suction on the right-hand side, we're going to do the same thing here with the pressure side of the system. The water kind of hits a T, or what should be a diverter valve, and on the left will be the spa, and on the right will be the pool. Here I am building the pressure side manifold for the swimming pool. So I have the 2.5-inch trunk line, and that is going to then break down to the individual return lines, which are 2-inch in size. On the other side of the T, we have the spa side. The spa, just like the suction side, doesn't really have a manifold so much as it just has the main trunk line itself. So we have the spa side on the left, and then the pool side with multiple return lines on the right. I could be gluing the valves in place up in the wall there, but I want to do everything I can to prevent any primer or glue from rolling or flowing down into the valve mechanism as I'm gluing it together here. I want to do everything I can to prevent that from happening, and that's why I'm gluing it together in the order that I'm doing it here, to minimize the chance of having any primer or solvent cement fouling these valves. These valves are too expensive to be, making mistakes and damaging them. And I guess if you wanted to be by the book, you should be removing the internals from the valve before you make these connections, just to ensure that you don't have a problem. But I'll be honest, it's just too much work for me. This is the way I do it. I ended up not having any problem with these valves after this installation. These 2-inch return lines after the pressure side manifold, this is something that I recommend to all swimming pool owners, or designers, I should say, like people who haven't built their pool yet. For a lot of pools, you just have one pipe, and this one pipe goes back and feeds all of your returns, 2 or 3 of them. I much prefer isolated return lines. It's a small investment in more pipe to be able to have individual return lines running to the individual return ports in your swimming pool. This gives you more flow potential, this gives you more flow efficiency, and most of all, the hallmark of a well-designed plumbing system, it gives you more flow control. It allows you to isolate the flow isolate and regulate the flow to each and every port in your system. I love doing this for suction as well as return side. Notably, on the suction side, a dual set of main drains needs one suction line shared between dual main drains as part of the VGBA, Virginia Graham-Baker Act, for anti-entrapment in swimming pools. But other than that, every pipe in your swimming pool, I prefer to be a dedicated, isolated pipe such that you have maximum flow control over your entire system. What I'm plumbing in right now is a line which shunts in between the pool return line and the spa return line. And the reason I'm installing this is a manual makeup valve. It consists of a line valve and a check valve. And what this allows me to do is manually have water diverting from the pool return side over to the spa return side. But when I'm on spa mode, water's unable to travel back in the other direction. The end result here is that I have an overflow from the spa into the pool when the system is operating on pool mode. Pool mode means 100% suction from the pool, 90% return to the pool, 10% return to the spa. That's what a common arrangement would be for a shared pool and spa system with a manual makeup valve like you see me installing here. Now, in theory, modern swimming pool installations do not require this manual valve configuration that you see me installing, this line which shunts in between the pool return and the spa return with a line valve and a check valve. A lot of modern pool systems, you can regulate the flow of filtered water to the spa every day through automation exclusively, thereby rendering that manual makeup valve installation redundant or unnecessary. But in my installation, I'm choosing to keep it because there's a lot of configurations that might need it, and it doesn't hurt things to be there, so that's why I've elected to keep it. But I do want to make that clear. That is something that you would have required for a shared pool and spa configuration in previous generations when our automation systems were less robust. Modern automation systems can make up for that manual spa overflow makeup installation just through the control of the digital valves and automation itself. Here, let's call it here. Oh, hey there, Johnson. Working hard or hardly working? It's going to be a hot one today. Well, let's just see how this installation's coming along. What? Wait a second. Who's been working on the test lab install? Steve, was that you? You're going to have to get in here and redo this. I don't know what you were thinking yesterday, but this is no good. I expect more from you. Well, it looks like somebody made a big bonehead mistake yesterday and failed to put the diverter valve where it needed to be in order to enable automation in the future for this system. So I don't know who did that. What? Huh? Me? No. Okay, maybe that was my mistake, but it was like a really long day and it was hot and I was tired and the sun was in my eyes and I'm allergic to PVC fumes. Like, look, I did my best, but I'm gonna have to make a change here. And true to the way that I like to do things, I'm going to have my video include warts and all, and I'll show you the mistakes, and I'll even include the part where I struggle to fix the mistakes. But it's actually not going to be that much of a struggle. We're going to do a couple things here. I need the diverter valve here. There's not enough room for it, so the first thing I'm going to do, make a cut here, and then I'm going to attempt to save this piece of PVC pipe by stripping all of this outside stuff off of here. I'm going to make a cut up there and add 1.5 inch coupling, and I was unhappy with how high I was on the wall here, so instead I'm going to reorient the T and have this line come straight out here, so bringing me down a couple inches on the wall. I like that, so that's just kind of convenient. I get to change that as part of this. In addition to these cuts here, I'm also going to go ahead, step back to here, and I'm going to install a digital flow meter. That was supposed to be an X. Okay, forget all that. We're just going to put a flow meter over this area somewhere. And we'll have the automation. We'll have the instrumentation to read the flow. I'll be able to stay a little bit lower on the wall, which is ultimately what I wanted to do because I have a couple of more pipe runs that are going to go above that still. So it should be fine. Just the trick with stuff like this is take your time. If I went at this with the idea like, this better be fixed within the hour, like you could very easily make a mistake, crack a pipe, do something wrong. That means you're gonna have to take more steps backwards and spend more money on pipes and fittings, like all this stuff. Like you can't really reuse that. I might get lucky and be able to reuse a small piece in the future, but usually this is just kind of like a waste, and it's not a big deal. Things like that are expected, especially with a room like this where I'm kind of just, not say making it up as I'm going, because I have a vague idea in my head what I'm doing here, but a little bit making it up as I'm going. So we're going to install the diverter valve here. We're going to install the flow meter over here. We're going to make some changes over to this area. Oh, and one more thing I'm going to do, I'm going to take this entire top section and I'm going to raise it by about 1 inch. The slip on these couplings is longer than what the PVC fittings are, so I need about 1 more inch for the clearances that I need. Step by step, we make it better. Used to be back in the day, I did most of my good work with a hacksaw blade. If I was lucky, it had a handle on it. Nowadays, I use a variable speed reciprocating Milwaukee M12 Hackzall because this is vastly superior to what I used to do. It's gonna make short work of this, but being that I'm wall mounted here, there's a lot of vibrations. You know, it's a little bit challenging, but again, the trick is just take your time and you'll get through it. This thing is awesome. Oh my gosh. Okay, so we got a couple leaks in the system here. Maybe just gonna put some 2-part epoxy on them and see if I can plug those up. I got all kinds of jokes because the more I'm joking, the less I'm working, and it's hot today. How hot is, no, just kidding. I was just talking about this earlier in the video about, make sure you don't leave too much space because there's a lot of stuff going on and you're going to run out of room, or, your equipment installation is going to be taking up too much space on the equipment pad. Well, basically I ran into this problem already. So as you can see, exiting the top of the screen there, I still have multiple pipe runs to put up there. And so that's why I'm going to have to go through this extra work here to make sure that I get every inch possible. You know, there's in reality, standing there working, there's lots of room for me to work with and loads of room for more pipe runs. But from a filming perspective, the very top of the screen is kind of like a bad spot for me. So I'm trying to keep everything as low as possible on the wall. Oh boy, I'm freezing in here. Oh, hey, somebody have a heater or something they could pass me? Oh yeah, awesome. That'll work. Thank you. Yeah. Ooh. Oh, oh, it's so nice. I'll tell you a lesson that I have learned the hard way before, and I want you to know it. You can do what I'm doing here and use a heat source, like a heat gun here, to heat up this pipe and remove the PVC connection like I've done. But you better be darn sure that you have aerated that pipe fully of all the PVC fumes, because the fumes themselves are the explosive part. So if you just make a bunch of solvent welded connections, glue it all together, come back the next day and just cut into the pipe and smell, and it is clearly filled entirely with PVC fumes, and those fumes are absolutely flammable. And I have in person seen this happen where using heat has caused an explosion within the pipe. Before I did this heating process, I had air blowing through these pipes for an extended period of time to make sure that there was no residual PVC fumes left whatsoever. Once I have the PVC warm, grab it with something like side cutters here or pliers, and it's all in the rolling technique. That's the way in which you strip this. And it's not a strength thing, it's just about applying consistent force. It lets go readily if it's warm enough. If it's not warm enough, it simply won't let go. It's important when you do this, you have to recognize that it's not letting go. Don't just brute force it. Stop, give it some more heat, and then continue with the rolling process. Good as new. It's good looking pipe boy. Don't you dare say it's a bad looking pipe. Take your side, beat the face off you now, boy. There is a ridge left over from the bead of the solvent cement that dried, and I'm cutting that away simply because the glue slip on the next fitting is longer than the old one. So that glue ridge could and would obstruct the fitting from sliding all the way along, and that's why I have to kind of cut this away. The primer isn't enough to remove that dry glue bead. I have to get rid of that entirely. So cut it away at first and then sand it clean to get a better connection and a fully deep flush fit with the new fitting that I'm installing. Okay, I think we got her done there. Went pretty easy. This was only glued recently. It's the older it is, the harder it would be. If that was a 10-year-old connection, it probably would have broken the pipe before it stripped away. And as you saw there, The trick isn't any sort of brute force, it's patience, it's even heating, and if any trick, it's that you're grabbing and rolling. When you roll it, it just peels away. It's really effective. So we've got this set up, we've got this set up, we've got the height clearance that we need here. I'm going to be able to make the change that I wanted to do there. We're just about ready to go ahead and throw on the gear and start solvent welding. We're about to get started with the solvent welding again, but before I do, I just want to introduce a product that I'm going to be installing here. It's not the product you see me installing right here. This is just something that needed to happen. I'm going to be installing a series of digital flow meters by FLOWVIS. And I'm going to locate one of them right here, which is why I'm talking about it right now. So here I have the FLOWVIS flow meter by H2flow, and there's a bunch of different components here. So at first we have the analog flow meter itself, and then we have the digital upgrade, which includes the digital readout screen, but also an adapter which fits onto the analog meter here, which enables the digital reading. So right now, we really don't need all of this stuff. In fact, there's only one single piece we need, and that's this guy right here, just the valve body itself. We don't even want the inside in it yet. I mean, like, if it was already put together, maybe I'd try to risk things and glue it in there without following the instructions and removing the insert first and then installing it. But since it comes out of the box like this, it's perfect. So we're going to install that right over there. And then at a later point, we're going to come back and we're going to install the analog meter as well as the digital upgrade to it. Now, since I have 2.5-inch trunk lines to connect the flow meter here, I'll be using a couple of 2.5-inch couplings, placing it in thusly. So now that I've told you what I'm doing, let's go ahead and mask up and we'll get started again with the solvent welding.
Ready to get started. I've tried all the other ones so far. Now I'm going to go to the one I like, which is the 705 clear. Okay, let's get started.
My test lab installation has a lot of points of instrumentation that the average residential swimming pool would not need to have. The thing I'm installing right now, the flow meter on the main trunk line on the pressure side of the system after the heater, but before the point of chlorine injection into the system, in this case a saltwater chlorine system. Every swimming pool is going to have this, or should have this, I should say, because not every swimming pool does have this. You'll have a variable speed swimming pool, which allows you to control the flow rates, but this flow meter I'm installing here is how you would know the actual flow that you're achieving. It's like the speedometer in your car. Pay attention to the order of operations when making a connection like this, because I've got this rigid T, and then I have, a rigid pipe from the bottom, a rigid pipe from the top. There's 3 rigid connections. There is a way to do this where everything just fits together cleanly, neatly, easily. There's a way you can do this where you kind of like paint yourself into the corner and you can't make the final connection. So pay attention to your order of operations when PVC plumbing like this. Here I'm prepping the pipes for something that I rarely do, which is I'm going to make two connections at the same time. And when you're plumbing PVC, you actually will often find yourself in a situation where two or even three connections seems like maybe this is a good idea. Rarely is it a good idea to be doing that. But sometimes two at the same time is right, like I'm doing here. But you have to be smart about this. No stress, no strain. You just want to have everything dry fit together such that it lines up, it fits perfectly, and then you primer and solvent cement both at the same time, and it should be an easy process. And occasionally this is normal when doing pool plumbing or PVC plumbing to have to do two connections at the same time like this. I'm installing a reducer bushing here simply because this is the spa side of the system here. I'm not worried about preserving the flow efficiency of the trunk line of the pool filtration system because remember, you're not in spa mode very often at all. Like well less than 1% of the time you're going to be in spa mode. 99% of the time this pool is going to be running in pool mode. And that's why the pool side trunk line is larger at 2.5 inches. But when we get to the spa side, bushing down to 2-inch pipe size is the right move here. I ended up installing this system on the hottest days of the year. And I know this because I'm voicing this over from a future point in time. And it just so happens that's how it was. And normally my shop is very cool and very comfortable to work in. And it was absolutely unbearably hot throughout the entire installation process here. And I did this over a few days' time, and it was pretty taxing to say the least. And it's a good thing that I had gone well out of my way to prepare myself for the physical intensity of installing a pool and spa system. I know it doesn't look like very much. I agree with you as I look at it. It doesn't look like very much to me. But physically speaking, it took a lot of work. There was a lot of mornings where I had trouble lifting my coffee cup to my mouth, but we got it done together, and I'm really happy that you're following along with me and watching this pool and spa installation video, and I appreciate you doing so. A lot of the mystery, so to speak, with a shared pool and spa system happens in that large three-way valve right in front of my face. That three-way valve, the point at which the water can either go left into the spa system or right into the pool system, is the defining point of function for these systems. And as you can see, yes, it does make it complicated. There are a bunch of valves in different directions that the flow of water can go, but ultimately it is this three-way valve which is the defining functional point of the system. There's one of these on the suction side and there's one of these on the pressure side, and that is what facilitates the ability for the pool to share the water in between the swimming pool and the hot tub. When it's in pool mode, it's 100% suction from the pool, and then about 90% return to the hot tub. A shared pool and spa system is confusing, and there's a lot of different configurations which can make it even more confusing than that. So just take away this. There's a pool side and there's a spa side, and that applies to the suction lines and then the return lines or the pressure side. So that's kind of the takeaway here. You've got a pool side of the system and you've got a spa side of the system, and they're connected through the plumbing lines. Well, here we are back on a new day, and things are going pretty well here. This works a lot harder than I remember it being. at least we didn't get another visit from Supervisor Mario. I can't stand that guy. So let's just keep going with what we're doing here. Now we're ready to start mounting some more unistrut on the walls, and then we can keep going with the pipe runs. Now, because this is a test lab, I'm going to have a bunch of different points of instrumentation, like things like flow meters. And you don't need to have these as an average swimming pool owner. At this point in the system, the only thing you would have would be a salt chlorine cell or a chlorine puck erosion feeder, and then the pipes returning to the pool and the hot tub. So now I'm going to be continuing the pipe runs here, starting with what are the supply lines to the spa, and then after that will be the supply lines to the pool. I can't stress this enough. All of this equipment's expensive. I'm going to be doing a bunch of solvent welding right over top of it. Take the time to cover it up. Even with like the clear primer and the clear glue, if you get some on the pump or the lid of the pump, it hazes it completely. Like there's a chemical reaction to the plastic. It damages it instantly. Even if you wiped it up immediately, you just made a mess out of somebody's brand new expensive piece of pool equipment. So take the time, cover up all this stuff so that you don't damage it with all this solvent welding. Okay. Choke points are something that you want to avoid in any plumbing system. We want efficient hydraulic flow, and what I'm doing here with this 2-inch T is a perfect example of the correct way to go about doing this. I have one 2-inch supply line, and I'm splitting that into 2 1.5-inch lines. So the wrong way would be to have an 1.5-inch T. What you want to do is you want to have a 2-inch T and have the larger diameter T have 2 reducing bushings like you see this one have. And then you can have a more efficient hydraulic separation of flow between the two sides. You're not creating an unnecessary restriction to flow here, or a choke point by having the T be too small. Keeping that trunk line or preserving the trunk line, even though we're all the way down to the spawn, it's only 2-inch in size, it's always important for efficient hydraulic flow. Okay, I've gone about as far as it can go here, dry fitting. As you can see, I'm not even really dry fitting. I'm just kind of piecing it together because some of these pieces of pipe could be give or take an inch and it doesn't matter. When I get to the point where it matters down to the 1/4 inch, I stop dry fitting and I start actually solvent welding the system together. So it's that time again to mask up and protect ourselves against the fumes from solvent welding. It is very hot today. Well, let's see how this goes. Something that I preach to my consulting clients is that when you're building a pool, you should have isolated plumbing lines. And that's why I have this T here. On the equipment pad, I'm splitting the 2-inch spa return line into 2 individual 1.5-inch return lines, which would go to the spa. That's what these are here. So what we would have is the main trunk line of flow coming from the heater, through the pump, through the filter, through the heater, through the diverter valve, to the spa side, now heading towards the hot tub, but we split into 2-inch-and-a-half pipes. One is going to go into the wall, one is going to go into the footwell. This is the way that I would normally design the system. And the reason why I have 2 pipes here instead of 1 pipe that runs all the way back to the hot tub and splits at the hot tub into the wall and footwell is I like isolated plumbing lines. I like to be able to control the amount. Maybe I'm getting green water in the footwell and I want 3/4 of my water diverting to the footwell. How can you do that if you're sharing pipes? You can't, but I can because I've split mine in the pump room here into isolated plumbing lines which are going to run back to the hot tub. And the same thing applies for the swimming pool side as well.
So here we have another FLOWVIS digital flow meter that I'm going to install. Again, we're only working with the valve body at this stage. We install all the stuff into it after we're done with all the plumbing. Remember I was talking about this heat bent pipe before, the little saddle offset that I made? Well, I'm going to try something a little bit harder here. Let's see how it turns out. Well, what do you think? I mean, come on, it's not perfect. I'll admit that. I did my best. There's a couple of waves in it. I did it out of a single piece of pipe, so there is that. I definitely get brownie points for that, no doubt about it. This is a tight radius bend. This is not swimming pool equipment installation protocol. Let's call this just a little bit of swimming pool Steve flair. I wanted to see just what I could get done with a heat gun and radius bending some pipe. I think I've accomplished something pretty good here. Yeah, just head on down to the plumbing store, pick up one of these guys and install it. It's good for flow efficiency.
Okay, and just to head off the questions that people are certainly going to give me about why is there a guitar installed in the plumbing configuration of this system? What purpose does this serve? It serves no purpose at all other than I wondered if I could do it, and ta-da, I can do it. Or at least like, an 8 or 9 out of 10. I'm pretty happy with it. I think it's kind of funny. It's kind of neat. It gives me a place to mount my guitar because I actually don't have a good spot to mount a guitar. And like, you don't know me. You think you know me because you think you know Swimming Pool Steve, but I'm actually Steve the guitar guy. Mwaha, you didn't know that. And I'm totally, absolutely a guitar nut. And that's why a guitar was the shape I went with.
Okay, so for this blue-white F2000 style digital flow meter, we've got male threads here, so I have to install a female adapter on each end and then plumb into that. Now, if you've made threaded connections before for pressure applications, you know I didn't need the silicone there. The Teflon tape is enough to make a seal. But I don't have any unions in the system here, and if I have a leak, it's going to be a problem for me. So two things the silicone is going to do for me. First, that's 100% silicone. It's not silicone caulking. It's going to provide a little bit of slickness to allow me to just get this to tighten on a little bit further than I would otherwise be able to get it on there. But that's not the only thing it's doing for me. It's also going to provide a watertight seal. Guaranteed that it's going to provide a watertight seal, which is what I'm looking for. I'm looking for the 100% guarantee here, and that's why we're using it. So go as far as you can go by hand, and then give each fitting half a turn to one turn further. I'm going to go do that now. Okay, so it's about one turn out of one side, 1.5 out of the other. And then, of course, that silicone is going to be allowed more than 24 hours to set up before I pressurize the system, so no problems there. Every time I glue a valve, you probably notice it. I glue it specifically such that the glue is not going to drip into the valve, it drips away from the valve. That's so important. You're totally going to ruin the valve if you let any glue or primer get in there. So, what happens if you get some in there? Like, I mean, these things happen. If you do nothing, you might be okay. However, if you, for any reason, turn the handle thinking maybe I can clean it or whatever, that's it. It's done. That valve is absolutely going to be sealed permanently, and you're not going to be able to turn the handle once that solvent, cement, or primer sets up. When you drip glue into a valve, just walk away, let it set up overnight, come the next day, and if you get lucky, you'll be able to crack it free, still be able to articulate the handle, and still be able to experience a total sealing of the valve when it's closed.
At this point, what I am plumbing is the equivalent of the trenches leading to your swimming pool. I'm hitting a point here where I'm splitting the pipe into individual lines that run directly into the swimming pool. If you're having trouble visualizing this, because this is a test lab, it's a little different than what a home installation would be. So the blue handled valves here, they are the last thing before the pipes leave the equipment pad installation. So everything past this blue handled valve represents the pipes in the ground running to and into your swimming pool and hot tub. That's the hot tub line that I'm working on right now. Again, the blue handle valve represents the pipe leaving the equipment pad. Just in general, that's how I've always plumbed pool equipment pads. Every pipe coming to and leaving the equipment pad gets a valve when it gets to the equipment pad. It's the first thing it gets is a valve. And so that's how I've always been able to maintain flow control over every single component on the equipment pad. The blue handled valves represent the end of the equipment pad and the pipes returning to the swimming pool and hot tub. Right now, I'm just taking a measurement here to cut a pipe and have it match the other pipe where I need it to in terms of spacing. A cut like this without one of these handheld saws on my wrong side. I'm a right-handed person, so that's, the wrong side for me to make this cut. That would have been such an ignorant pain in the arse to do that without one of those variable speed saws. I can't even tell you. I would have called it a day before I had to make a cut like that. And instead, it's just 2 seconds worth of work, no sweat at all. Absolutely love that little thing.
I think it's time we go back over there and we pick up the pool return lines. That's the spa side done now, plus the guitar. Sounds great. Let's go work on these plumbing lines here and see how much further we can get this today. Okay, we're ready to keep going here. We're going to continue on with the pool return line. And then above that, we're going to have the autofill connect here. And then when we bring the top line across there, that one is also going to contain the salt chlorination cell, the saltwater chlorination cell.
I guess I'll just go ahead and address it here. This little orange torpedo level that I'm using here is such a clutch item to have. You have to have this tool when installing PVC pool plumbing because it fits readily in your side pocket and you can just have it on you at all times because you only have just seconds to work with when you're solvent welding PVC, especially in the heat like I'm doing here, and having it at the ready so that I can check and make sure that everything is plumb, everything is square. This is how you ensure what is a quality PVC pipe installation. It's probably one of the most important tools I'm using, so I just wanted to give it a specific shout out here to the small torpedo level. Highly recommended if you're going to be doing a lot of this kind of work. Really, any of this work.
At this point, I'm making provisions for the LevelSmart autofiller from H2flow, and it has a solenoid actuated valve that's going to allow pressurized water into the system to fill anytime I need water. For now, all I need to do is add a provision here that I'm going to run this 1-inch solenoid valve piping into. For now, I'm just going to put a 2-inch T up there and we'll leave it open, and we'll plumb that fill valve in last. So here on this line, I'm going to be installing another FLOWVIS digital flow meter. And so it looks just like the regular flow meter, but look, it's got this additional attachment on here. I mean, we'll go over more of that later, but if you're wondering why that is, this is from my last test lab, and I'm going to be reusing that on this one here, and this is where we're going to locate it up here. Time to install the salt cell here. So it comes with unions, and you put the unions on, we plumb into that. There's a flow switch as well. We need specific spacing for each of these, so I'm just going to line this up and see how it's going to fit.
Well, here we are starting week 2 of the installation. I wouldn't say this represents a full week worth of work for a pool plumber to install. I think an able-bodied person would be able to do this in a couple of days maximum. But I'm also, in addition to installing it, filming and stuff like that, and I also chose the hottest week of the year to do so. So, you know, working with a little stuff behind the scenes here, struggling just a little bit to keep up with the physicality of this. There's a reason I don't do this work anymore. And I gotta be honest, I prepared for this. Like, I trained for this. Like, I'm training for a marathon or a jiu-jitsu tournament or something. I lost 40 pounds getting ready to do this installation here for you guys on YouTube. And it's going really well, but it's been a lot of work behind the scenes for me to do this. And I would like to take this opportunity just to ask you, please, if this is helpful for you, please like and subscribe. I put so much work and preparation into making this video series that you're watching right now, and it would mean a lot to me if you like and subscribe. Here's the deal. I'm the pool expert on YouTube. That's why you should subscribe. It's not even just this one video or what I had to go through to make it happen. It's because you're not going to get better advice. You might find a flashier video or somebody's better at animations or something like that, but nobody knows swimming pools better than me on YouTube. That's a compelling reason for you to like and subscribe to this YouTube channel. So let's get back to this installation. We still have a long way to go, and throughout the process as we're going here, I'm making small design changes, things like that. I'll keep you updated to the pertinent details as they come up. For now, we're going to be installing the autofill line. This is a great feature. Most pools don't even have an autofill, and if they are lucky enough to have one, they probably have a very old school analog canister with a float valve, just like you find in the back of your toilet. It's exactly the same thing. And it totally works. There's nothing wrong with it. And it saves you from having to drag out the garden hose and fill up the pool, you know. And people always think, well, big deal. Just drag out the hose every now and again and fill up the pool, right? Here's the thing. You don't really appreciate how much water you lose to evaporation in a swimming pool. Like, let's talk about a 20 by 40 swimming pool, a pretty big residential swimming pool. If you lost an inch of water in that swimming pool, that is 500 gallons of water. And you're going to lose an inch of water a week to evaporation for sure, in a lot more in some areas. So you're actually dragging out that garden hose pretty often and topping it up. And to alleviate this maintenance point, to make your work schedule easier for caring for the pool, you can install an autofill unit. Now, what's really interesting about this autofill unit from H2flow is that it has a component which installs in the skimmer of your pool. and that component operates independently. There's not like a wire that needs to snake all the way from your pool equipment area all the way to the skimmer, because that wouldn't really work very well for most retrofit applications. It would pretty much only apply to new construction installations, which is what you would use one of those analog water fill for. You can't install that after the fact in a finished swimming pool, but you can with one of these digitally controlled solenoid actuated automatic water fill units from H2flow. So installing this unit is actually very simple. You're going to need a pressurized water supply from your house. You're going to need to have a backflow preventer to prevent pool water escaping into your city water system. That would be very bad. And then you're going to provide this pressurized water line up to a solenoid, and that solenoid will activate, releasing the pressurized water from your house system into your swimming pool system. And if you're wondering, well, wait a second here, you got a pressurized pool system. How are we going to get water into that with your house supply? The answer is very simple. Swimming pools operate between 0 and 30 psi. This is the range. And 30 isn't like, I mean, that's kind of an extreme case. That is the maximum you can operate pool equipment at. The water supply in most municipalities is somewhere in the range of 50 to 60 psi. That's how much pressure you have in your home plumbing system. So right away, there's for sure twice as much pressure in the house water supply as there is in your pool system at any given time, and that's how it's able to safely release the water into your system without just backfeeding in the wrong direction. Of course, the backflow preventer stops that anyway. I'm just explaining how the pressure system equalizes such that the house supply is greater than the pressure of the pool supply, and that's why it's able to do so. This is the solenoid valve from the LevelSmart system. It is a 1-inch female thread, so you'll need to have a couple of 1-inch male adapters to connect to this. I'm going to make the same connection here that I would for, let's say, a flow meter, which is I'm going to use Teflon tape, but then I'm also going to add silicone to that. And the reason why is because I don't want to have to crank this in so far as to bury it or to create too much pressure that could crack this fitting here. I'm not saying this fitting would crack. Maybe this thing is darn near impenetrable, but I don't know that. I haven't worked with it before. I just know that often when you're dealing with plastic threads, if you over tighten, you can crack the receiving flange. It's a very common thing. And so to just avoid that entirely, I'm going to give it a good amount of, hand tight plus a quarter turn, hand tight plus a half turn, something like that. But I'm going to add the silicone as well. And that's going to ensure after 24 hours that I have a leak-free connection at this point here. One other point that I would want you to know, and this is very, very important when you're installing the LevelSmart system here, the solenoid valve is flow dependent. There's a little arrow there which indicates the direction of travel for the water. Very important to observe that when you're installing the solenoid. It's important to know with the LevelSmart system, because it is a wireless system, we're going to have the obvious question, well, what's the range of this thing? Because maybe your pool is pretty far from where your pool equipment is located. And the answer is there's 1,000 feet of range for this unit. So it's very unlikely in any residential application that your equipment is going to be too far from the skimmer where you're going to mount the level sensor. So 1,000 feet gives a lot of room to work with.
All right, let's get started. Going back to the 7-Eleven gray just for a couple more connections, just to add some more color to the wall.
I really like this approach to automatic water fill systems for swimming pools. Now, this is something that I dealt with extensively, back when I was building swimming pools, which admittedly was a long time ago, but I did a lot of it, and I did it in a very high-end area, and it was every swimming pool. Every swimming pool had an automatic water fill unit. I live in an area now where there couldn't be more than 5 out of 100 pools have automatic water fill units. But in the, the more affluent areas, like if you've got a bunch of gunite or concrete swimming pools in your area, then likely a lot of them have automatic water fill units. Traditionally speaking, this has meant that adjacent to the swimming pool, like, maybe next to the skimmer, there will be a physical canister that is installed, and that canister will retain a float valve mechanism, the exact same kind of float valve like you'd have in a toilet tank reservoir. And as the water level goes up, a little piece of styrofoam block floats up or down, and this actuates a lever arm which opens or closes a pressurized fill line for the pool. So it's a pretty nifty little system, and it works just fine. But I've never loved them. They're a little finicky in terms of setting the water level in areas where you have, seasonality or you have freezing winter climates. I've found that they've been a little bit inclined to be. They're not a problem, but it's difficult to winterize them. Some things are easier, some things are harder. It's one of the more difficult things to winterize, and as a result, they fail a little more often than I'd like to see them failing. And just this approach to using a totally remote system for installing the automatic water fill, this is a great rethink to building swimming pools. There's no need at all to have any provisions whatsoever poolside other than this wireless transmitter, which you just mix up a tiny little bit of two-part epoxy and stick it into the skimmer mouth. That's it. You're done. And it transmits the signal to this, solenoid receiver that I'm working on here, and it puts water into the pool. This is a great approach. That way the pressurized water line stays in your equipment room here where we're doing all of this plumbing work, where you have all the pressurized water lines already. This is the place where it should be. I've never loved running this very small diameter, high pressure water line out to swimming pool areas. It's just, they break more often than they should, like I said, as winterizing, but even just from workers stepping on them as you're building a swimming pool, there's a lot going on and not everybody's as careful as they should be. A small diameter pipe like that is easy to step on and easy to break, and I like this whole approach to avoiding it. It makes sense to me. There's a couple of manufacturers that have started to introduce products like this. Like, I've seen them before, but this is the first time that I'm using one for myself, and I have to say, I love this idea. Here's a tip for plumbing PVC and making solvent welded connections. You know that feeling where you make the connection and you press the pipe all the way to the bottom of the fitting, and if you let go too early, it starts to back itself out? Well, small diameter plumbing, like what I'm working on here, this stuff is much more inclined to do that than the larger diameter stuff. And the problem here is that the length of the slip of the joint physically is very small. So you have to be pretty careful when you're working with this little pipe to make sure that you bury the fitting or the pipe completely into the fitting and really go out of your way to hold it there for a good couple of seconds, because you really don't want it to back off at all, because backing off at all could represent 10, 15, 20% of the total depth of the fitting, which wouldn't be ideal. What I have here is a dual union ball valve. If I'm going to use a ball valve, I'm going to use a ball valve that has unions. The more unions it has, the better the quality of the valve. So I want a reasonably high quality valve here, and so I've gone ahead and used a dual union PVC ball valve. It's not my first choice, but for this smaller stuff, it's not too bad. And notably, this is not a non-union valve. Non-union ball valves are the lowest of the low. I wouldn't use them if I got a dump truck full of them for free. Make sure that your PVC ball valves, if you're going to use them, at minimum they have one union, or ideally dual union like you see on this little red-handled valve here. for now, I'm just going to send this water line out the right-hand side of the picture here, along with the heater pipes, and that way I can, behind the scenes, run this over to my freshwater supply, just like I've done with the heater, running it to the outdoor heater. Well, now it's time to install the Hayward HydraPure AOP hydroxyl radical generator. Sure is a mouthful. You know what? It's probably not going to take much longer to say it than it is to install it, because we've kind of already got it set up here. We've got a 3-zone bypass. So we've got the 2.5-inch trunk line, and then off of that, we have these 2-inch bypass zones here. So what this allows me to do is control and regulate the flow of water going to this unit here. It has a maximum design flow rate of 120 gallons per minute. You don't want to exceed that number. It's possible my system's going to exceed that number, especially if I put a larger or more powerful pump on it for future testing. So I need to locate it off of the trunk line to protect this from flow rates in excess of 120 gallons per minute. In addition to that, there's a specific advantage to keeping your flow rate at 80 gallons per minute or less with this unit. You can have a higher flow rate from that 80 to 120 range, but you're going to lose something important. This unit at 80 gallons per minute or less has a 99.9% sterilization rate for the contaminants in your water, which is really good. That's why you're installing something like this. So ideally, you're going to install it, you're going to locate it on some sort of zoned bypass, and you're going to regulate the flow of water to it such that really 80 gallons per minute or less is the ideal number reaching the AOP unit. As far as reaching the AOP unit goes, it has an in-port and an out-port Hayward standard 2-inch by 2.5-inch CPVC unions. This is going to be 2-inch, so we're not utilizing that 2.5-inch advantage there. It's just not needed in this particular instance. And then we've got the line coming from the pump. It's going to go through here into the inlet, which is the bottom port on the AOP unit. Then it comes out of the AOP unit and reconnects back into the system. That's all it takes to install these, other than the electrical connection and the bonding wire, of course. So that's it. That's how you install the Hayward HydraPure. Let's get started.
So here we have the AOP unit sitting where I want it. I'm going to attach a couple screws into the feet. Residentially speaking, people don't always do that. Commercial, you always see that. But my floor isn't quite level, so I'm just going to bolt it right to the floor to make sure it's not moving around on me.
I have to admit, I'm pretty excited to be installing a hydroxyl radical generator. I'm not shy to admit that I'm a little bit of a nerd. I do like technology stuff. I'm certainly a person whom professionally preaches like tried and true. We want to go with tried and true when it comes to swimming pools. That being said, I'm always interested in the latest and greatest technologies that exist. You know, the swimming pool industry largely is kind of like a forgotten industry. We lag behind pretty much every other mainstream industry. It is what it is. But as a result, we don't necessarily get the latest and greatest stuff. And, you know, there's a good mixture of peripherally useful stuff, or maybe even some stuff on the market which isn't useful at all. And so it kind of creates for this uncertain marketplace. Pool buyers don't know what to buy, what's kind of snake oil, what works, what doesn't. It's interesting to me to be installing this hydroxyl radical generator, because this is basically the newest high-tech stuff that we have in terms of how to keep water clear in swimming pools. And what it all boils down to is this is an oxidizer product. An oxidizer is something that's familiar to swimming pools. We use oxidizers readily in pools, whether you realize that or not. Like, have you ever heard of like an ozone system? Do you know how ozone system, you know, keeps water clean or improves water quality? It does it through oxidizing the water. Well, the same thing could be said for a germicidal UV lamp. It oxidizes the water. Or chlorine itself is a sanitizer, so it sanitizes the water, but also it's an oxidizer. It's a chemical oxidizer, and it oxidizes the contaminants and organic debris in the water. And that's what this hydroxyl radical generator does. The Hayward HydraPure unit is like an oxidizer on every steroid on the market. It's a million times faster than ozone or UV at oxidizing would be independently. It's the latest, greatest thing. I'm excited to have one, and I'm really encouraged by the simplicity of the installation here. Just your line in and out, plus your electrical connection, and that's it. Up to 80 gallons per minute, we're receiving 99.9% sterilization rate of the water. This is fantastic. It's not the cheapest thing out there, and it's not something that every pool needs, but the bigger your pool is, the more organic contaminants that you have, the more swimmers that you have. If you've got a pool with 20 golden retrievers swimming in it every day, or you've got, yours is the party pool and everyone on the block and all the kids of the neighborhood are swimming all the time, you benefit most from installing something like the Hayward HydraPure on your pool. The average swimming pool, just a small backyard pool that gets used maybe once a week, on the weekend, like, you probably don't need this. Sure, it would benefit you, but it would take you too long to return on your investment. Unless the absolute highest level of water quality is important to you, then you wouldn't necessarily spend the money on that. If you're of the opinion that you want the highest quality water that money can buy, bar none, probably you should be looking at an AOP system for your pool.
Okay. And there we have our AOP installed, complete with a bypass and even a flow meter so we can monitor how much water we're sending into this bad boy. Let's keep rolling.
So, great news. I just had a visit from Supervisor Mario, and we had a spirited discussion about how well it's going with the installation here. And he had some really enthusiastic feedback for some potential improvements that he would like to see here. So, with that in mind, we'll go ahead and we'll start making some of these improvements that Mario has suggested. I mean, he's not wrong. Like, this is supposed to go here, and there's not enough room. And I mean, you're like, Steve, are you just making the stuff up as you're going? And to that, I would rebut, you're making it up as you're going. Let's fix it. Okay, let's review the changes. that we're going to make. We are going to cut right here and cut right here. And we're going to remove that one from the top, and I'm going to move this one down one line because it requires less space clearance. So this one's going to work on the bottom here, and I'm going to take the larger yellow meter, going to flip it to the top, reinstall that up here. We're going to take the FLOWVIS digital and we're going to install that here, so we'll end up cutting this pipe, you know, somewhere about there. So again, 1 cut, 2 cuts, 3 cuts. Then we're going to have to strip out this fitting and hopefully reuse that coupling. Let's see if that goes well. And then on this side, kind of the same thing. We're going to cut here and strip off this stuff. And then hopefully we can reuse that section of pipe by putting a coupling onto it. And then we can reattach this down here and all should be good. We'll start with the easy one. Alrighty. So, what are we going to do here? Well, I need this pipe long enough to glue a coupling on, so I'm going to just nip that off right there. Okay, so far so good. I mean, I could break this thing accidentally, and then I have no choice. I have to buy a new one of these, and it's a couple $100, and I'm not made of money. I don't know about you. I've had people bust my chops before on this YouTube channel for doing repairs just like this. Oh, I've got this thing, I want to reuse it, I need to strip this off of here. You can totally do it. It takes just a couple of minutes to do. And if you're careful about what you're doing, there's no damage to the pipe. You're able to do that and make a new solvent welded connection. Everything is good. The problem is it takes a couple of minutes. It takes a little bit of skill, and you know, for some people, I guess maybe it's just not worth the time, and it's more worth the effort. Just go ahead and get a new one. You know, what's a few $100s? Well, for me, it's a few $100s, and I'm going to reuse this one. So this is actually kind of interesting as far as this type of repair goes. This one has 2 different styles. So the first one, I'm stripping the outside of the fitting. I'm going to cut like a channel, kind of like that. And then I'm going to heat it up and I'm going to pop that channel out. Then I'm going to heat the rest of it and peel that outside ring off. This one's the easy one, no problem. So the other one, a little bit harder, is on the inside. I'm going to have to do the same thing where I cut a little channel, but this one's on the inside of the pipe. And then I'm going to heat that pipe up and I'm going to try to peel and roll that piece of pipe out of there such that I can sand and reuse this coupling with a solvent weld. Sometimes as you roll that pipe, the outside fitting cracks. The older the connection is, the more likely it is to crack. I've tried this with new connections. It almost always works. And by new, I mean a day, a week, a month old. I've tried this with connections that are 20 years old, and I'm not sure I've ever had one that worked. And I don't know if it's because the weld has become stronger or because the pipe has become older and more brittle. And that's especially true if it's been exposed to 20 years of UV damage from direct sun. Chances are that the coupling is substantially weaker than it used to be when it was originally manufactured. Regardless, I don't know what the reason for is. I have a high expectation that I'm going to be able to strip this fitting out here, reuse this whole assembly, and save myself some money. Let's get started. What we're going for is I want to cut the exterior fitting. I don't want to touch or even gouge that pipe at all. And if I've done a good job, that's what I've accomplished here. Let's get some heat on that and see if we can't strip that out of there. Gentle, even heating is the key here. You don't want to scorch it. First piece out. All right, let's keep her going. There we go. One down. That was the easy one. That worked really well. I don't have any concerns at all for that. Would I do this for a buried connection on a swimming pool? Probably not. I don't think I would do that. I wouldn't like to do anything that's even remotely hokey for an underground connection. For above ground in my test lab here, saving me hundreds of dollars. You bet this is easy. Maybe, if I'm honest, with a fair critique, I went just a little too far with the heat on this last removal here, just knowing that when you peel out that inside, that's when it can or will crack the outside fitting, especially if you're trying to do this in cold weather. The cold plastic just snaps so readily. In this case, I think I gave it a little bit too much heat, and I could see the coupling was distorting ever so slightly as I was peeling that inside out, which is why I've taken this piece of pipe and I've fitted in there to make sure that this pipe is going to retain its original shape here. It's really only the very tip here of the coupling. I still have a full inch of slip, which was not flexing. So again, I'm totally happy with this for above ground, but I'd like to be fair and critique when things could be better. And I think if I used just a little less heat there, I don't think I would have had any problem getting that fitting stripped out. Okay, it's ready to go again. It's gonna go right up there. What is the point of all of these flow meters? And the answer to that simply is that this is a test lab installation where I'm simulating a real swimming pool and hot tub installation, trying to recreate the parameters as closely as possible, and then most specifically monitor things like flow rate, monitor things like electrical consumption. This is going to enable me to make reasonable conclusions about the swimming pool system. Like, for example, that yellow flow meter that I'm installing on the top line there will tell me the amount of GPM, gallons per minute, required in order for that salt chlorine generation cell on the left there to turn on. You know, in theory, it doesn't matter, right? The salt cell will turn on when it gets the flow rate it needs. But in a test lab situation, it sure would be useful to know the exact gallons per minute required in order to achieve that. And that's an example of why I'm taking extra time to install more instrumentation than you would normally see on a swimming pool system.
Okay, here we are. Just going to bring these return lines down into the pool, and that's it.
This part of the plumbing system that I'm installing now represents the end of the equipment pad. So I've got individual return lines for the pool, 2 of them currently, and I'm sending these towards the direction of the swimming pool. Breaking up the pool return lines into multiple pipes, and then I'm going to be adding valves to each of these lines. In addition, for the valves allowing me to isolate the plumbing lines, they also allow for a small amount of flow control. For example, I could throttle the valves closed slightly, and this is going to have a dramatic effect on the total resistance to flow that the system is offering to the pump. And as a result, the power consumption and flow rate of the pump would change. So the addition of all of the valves on the system here allow me to isolate the lines individually, but also allow me to change system parameters for testing purposes. If you're wondering why I'm using these blue-handled ball valves here in place of the diverter valves that you've seen me use elsewhere, it's simply because the valves that I wanted to use were on back order. I was installing this during a popular time of year, and these are very, very popular valves from Jandy, and they were on back order, and I couldn't wait. I had these valves, and you know what? I don't mind them. I don't mind a Prayer single union ball valve. That's the brand that I'm using here, and I don't mind them. I've used them successfully for years. They're admittedly a lower end product than a Jandy diverter valve, but they're also a lower cost product. And there's a right place and right time for everything. So I do prefer to use a Jandy diverter valve here, and if they had not been on back order, I absolutely would have used them, but since they were and I had these, I went ahead and used these single union ball valves from Prayer. The pipes I'm installing right now, I'm in the process of reducing from 2-inch down to 1.5 inch in size. The reason that I would do this is I'm again simulating what a real swimming pool and hot tub environment would be like. And further to that, we could maybe have a discussion right now about actual flow velocity and the amount of efficiency loss that you would experience to friction and turbulence in a pool system. And just to throw some numbers out at you to give us a starting point to talk about this, is 6 feet per second of flow velocity represents the point at which beyond there's an appreciable and sharp efficiency loss to friction and turbulence. There is friction loss and turbulence before that, but that's the point at which there's an appreciable sharp increase in our efficiency losses. So we want to stay below these numbers. So 6 feet per second of water velocity in 1.5 inch pipe is about 38 gallons per minute. In a 2-inch pipe, it's about 65 gallons per minute. And in a 2.5 inch pipe, it's about 90 gallons per minute. So this gives us some, some numbers to start working with here. And so with my system, there's going to be an advantage to me to operate at less than 90 gallons per minute because I have a 2.5 inch trunk line through the system, and I've just said that beyond 90 gallons per minute in 2.5 inch pipe, I'm going to have a lot of efficiency losses, which I don't want to have. So these are kind of like the starting point for how you break this down. So I've got 90 gallons per minute running through the trunk line, but I've split that into two 2-inch lines for the pool returns, and that's what I'm working on here. And then I split that further into 3.5-inch pipes that are going for the pool returns. So you can kind of see how the flow breaks down. We've got 90 gallons per minute through the singular trunk line. When we go to 2-inch lines, we have 2 of them. Each one could handle 65 gallons per minute before we're experiencing appreciable losses. So we're still good there because we only had 90 gallons per minute to start with. So that's only 45 each. No problem. We're still good. When we get to 1.5-inch pipes, you might wonder, are 1.5-inch pipes too small? That's kind of the question I'm tackling here, but here's how you look at it. Each 1.5-inch pipe can handle up to 38 gallons per minute, and that's going to be about 6 feet per second of flow velocity, and that's still going to be well within the optimal range for efficient flow of water. So I've got 3 of them. I should be fine here because that's essentially the 90 gallons per minute that we're going to have flowing through the trunk line, optimally speaking. So that's the way in which you look at flow, velocity, gallons per minute, and pipe size together as a package. What I'm doing here is gluing bushings, reducer bushings, that are 3/4 inch in size. And the reason I'm doing this is to simulate the reduction in orifice size that you would experience with a return eyelet in your swimming pool. as you know, the swimming pool returns aren't just a flush cut pipe, a hole in the side of your pool wall, or they're not really supposed to be. They're not usually anyway. They're usually like an eyelet of some kind. So that's what I'm doing here by gluing on these reducing bushings into these pipes, and then bring them into my water lab test tank, or the test tank for my water tank for my test lab. That's it. That's what I was going after there. The whole point of this is to recreate the same restriction to flow that real swimming pool and spa systems experience, such that the numbers that I'm getting, the values for flow rate and electrical consumption, will be as true to real life as possible, and thereby making them more useful to you as the pool owner. These first two pipes entering the tank represent the spa return lines. We have two individual return lines headed towards the hot tub, and these are them. Now I'm going to work on the three swimming pool return lines. And basically we just have three individual lines. I've gone with three because two wasn't enough to run them 1.5 inches, and I wanted to step them down to 1.5 inch size plumbing here, so that's why I had to add a third line in here to make sure that I wasn't adding an unnecessary restriction to flow for my 2.5 inch trunk line. With that being said, I'll be honest, there was a different plan here. There was a whole different plan here, and I'm pretty sure it's going to end up happening in the future. So I'll just kind of describe briefly what I was going to do. I mentioned earlier that the valves I was looking for were on back orders, and this was kind of a change because the original plan was I'm going to add circles of PVC, flexible PVC pipe, because I can add 20 feet, 50 feet, 100 feet of length to each of these pipes. And that's ideally what I want to do here, because I want the flow restriction and the numbers for my flow rate and my electrical consumption to most accurately represent what a real world swimming pool installation is. And I can't really do that when I don't have enough length. I don't have enough distance. And so that's why the original plan was to install maybe hanging brackets with 4 different individual loops of flexible PVC pipe, something that's commonly used for swimming pool installations in some areas. I was going to hang up some loops. Maybe you saw the flexible PVC in one of my videos earlier where I was, kind of showing off all the different stuff I was going to be installing. I had a bunch of flex PVC there. That's why it was there. It was supposed to go in this location where I'm installing these, ball valves now and this straight pipe. I'm happy with what we've got here, and it's definitely good enough for now. But in the future, it wouldn't shock me if I saw a little change come to this area of the test lab.
It's quitting time.
Well, I was pretty sore after the end of the last day, so I'm going to take it pretty easy today. Just put on some unistrut clamps, straighten up a couple of these pipes, just take it one step further. Okay, now just this part. See about moving you over here. That's a little bit better. Now you can see what I'm working on as well here. I suppose you want to see what I'm doing. I guess that's the point of this YouTube video. Well, fine. Take a look at it, why don't you? I do not have enough unistrut clamps here. I've only got 4, so I'm going to do the outside 4 here. Now we're looking at the booster pump installation, and we're going to make a design change here, and I want to share with you the reasoning why we're making this design change. So this pump, do we even need it? Could you just use the other pump? I mean, you could use the filtration and heating pump to run the massage jets. It is something you can do. It is a compromise. You're going to get way less flow and less performance from your massage jets, and that's probably not something that you want. So I definitely recommend, even with a shared pool and spa system, have dedicated pumps for each thing. If you need filtration and heating, that's one. You definitely need that. That's one pump. If you want massage jets, which you should have, that's a second pump. If you want a big water feature or deck jets, that's a third pump. You should have one pump for each thing that it's supposed to do. Can you do it other ways? Definitely. I mean, there's no just one way to build a pool, but I would say that the better designers would agree that each feature should have a dedicated pump and pipes sized for its specific application. There's definitely a host of downsides to sharing a pump for massage jets, so we're not doing it here. We're going to use a dedicated massage jet pump. But you know what? This filter that we were going to use, first of all, do you need a filter for massage jets? And the answer is no. You would only need a filter if you were going through something with a restricted nozzle, like a shear descent waterfall. Those are notorious for needing a filter. The tiniest little bit of debris is going to obstruct that shear descent opening, and it's going to break that laminar flow of water, and now it's going to look all funny, and it's going to be really hard to fix as well. So those you use a filter on. For massage jets, you typically don't, because you don't need it. We already have a filter doing all the filtration for us. What would you need it for? You really don't. And this one has a maximum design flow rate of 120 gallons per minute. This pump, being that we're installing it with large diameter plumbing and with a minimal of a minimal of additional items, no filter, no heater, no sanitizer, anything like that. It's just big pipes into the pump, big pipes back out to the hot tub to run the hot tub jets. And so we're going to have a pretty high flow rate. And I definitely don't want to be exceeding the maximum design flow rate for this filter. That, combined with the fact that we just simply do not need it because we're not using a shear waterfall or anything like that, we can go ahead and delete this, and we will. And it's going to give us a little bit more room to work with this pump here, which is good because we're going to be installing it with 3-inch suction and 2.5-inch return. So let's get this guy out of the way here. I mean, I could just have a larger filter with a larger or higher maximum flow rate. Like this C4030 would allow for 140 gallons per minute. And there's more. I mean, there's ones even higher than that. It's just not needed for this application. And further to that, not needed, it's detrimental to the application because we want maximum flow. That's what massage jets are all about. So we want maximum flow, and anything that we put in there that's not needed is restricting the flow for no reason and just compromising the performance of our massage jets. So we're going to install the pump like this, and I think we're pretty much ready to get started. Right before we mask up here and get started with the solvent welding, I think I need to slide this unistrut just a couple inches over. So I'm going to work on that now, and then I'll get geared up with the mask. Just like when we started the filtration pump here, I'm going to start with the easy stuff. I know that I'm using 3-inch pipe. I know I need 5 times the pipe diameter in a straight run here. So I'm just going to have 15 inches of 3-inch pipe here to start. And then I'm going to hit a 90, come up the top here. At the pressure side, I'm going to come out with a 90 and a 45. So then we'll have the 2 pipes parallel here. We'll have a couple of flow meters and check valves and good stuff like that. But that's how we start with a pump installation. I usually just start with the easy stuff, start gluing things where I'm not committed. You know, right here it's just a straight piece of pipe. I know I need it, so that's a good place to get started. Once you've made that initial suction connection, and in my case, clamp the unistrut clamp the pipe to the strut, it's going to be very rigid. Actually, that one's not tight yet. There we go, very rigid. Let me fix that one up before I forget. I'm going to mention this because somebody is going to comment on this video. They're going to be like, oh, hey, you're not using the unistrut clamps properly. You're using a standard screwdriver in your finger. Like, why don't you get a ratchet on there or something like that? And the reason why I do it like this is not because I don't own the proper tools for the job. It's because these strut clamps get used for EMT, electromechanical tubing. It's what you would have like, it's basically the metal version of this, and it's used for conduit, commonly for electrical systems. Here's the problem: is these clamps are designed to hold that EMT, which is heavy, and hold it like for giant expanses with heavy gauge wire inside of it, things like that. For PVC pipe, this is so overkill. It's so easy to crack the pipe. If I were to use a ratchet on here, even just not paying attention for 1 second, and I'm gonna crack that pipe. Like holding the nut with my fingers, there exists the possibility I'm gonna crack the pipe with a standard screwdriver. So that's the reason why that I use the method that I do, not using tools that look like they'd make a lot easier work of it. They're just simply too much leverage, too much force for this very, very relatively weak pipe versus the strength of this clamp here. So as I was saying, now that we have the 3-inch pipe on the intake strapped to the unistrut, it's now rigid, it's firmly in place, and it gives me a stable platform from which to start building my plumbing from. I think I've talked all I can here. I can't avoid it anymore. Time to mask up and start solvent welding this stuff together. We're almost done. This is going great. As you can see, I'm always sure to cover up the pumps and other equipment before I start with the solvent welding. You know, the aim is to keep it all under control, but I can tell you from experience, you just have a way of, you know, getting some drips, or worst case scenario, knocking something over. Better to just protect the equipment, and it'll make it, you know, easier for everybody in the finished product, or better for everybody in the finished product. So starting to glue this together here, it's worth mentioning that the larger the pipe diameter you're working with, the more difficult the job becomes. It's not to say it's, you know, rocket science. It's not super hard or anything like that. It's just a little bit harder. You know, 1.5-inch pipe is pretty easy to put together. 3-inch pipe, you got to push a little harder to put the fittings together. The, you know, measurement of your pipe cuts, things like that, are all the more important. And so I would just recommend to take your time, because if you botch a fitting with 1.5-inch pipe, it might cost you, I don't know, $1 or $2, whatever the case is. Botch a 3-inch fitting or 3-inch valve, like what I'm holding and putting together here. Like that 3-inch valve, I don't even want to tell you how much it is. They're a lot of money. This stuff's expensive, and the larger the pipe diameter you're working with, the more expensive it is, and the price climbs dramatically in the larger pipe sizes. So just take your time. It's all the same stuff as before with the small pipe. Measure carefully, cut carefully, have square pipe cuts, deburr them, and you know, it's really just about that. Primer, solvent, cement, push them together, hold them together, make sure everything is plumb and square. But with the larger pipe sizes, just take your time a little bit more so than with the smaller stuff. So what you see here is a line valve as well as a check valve. Now, technically speaking, a check valve on the suction side of a plumbing system is referred to as a foot valve. It is, technically speaking, a significant restriction to flow. It's not something that you just add in if you don't need it, but this is a massage jet system I'm installing here, and the function of the foot valve in this situation is to make sure that once this pump is primed, it never loses prime. And when you hit the button for it to go, it goes immediately. It doesn't need to purge a bunch of air and kind of clear its throat. It's fully primed. It's ready to rock at all times. And that's what the addition of the check valve here on the suction side does for a massage jet system.
Some helpful person put stickers all over my pipe. And I'm sure that made it really easy for them to ship it to me, but it makes it really hard for me to clean this up and get a secure connection that I can be confident with. I could use the primer to take off this glue residue, which is left over after I've scraped it with my razor knife, but there's a better product for this. That's what this product here, Pool Cleaner from Weld-On, is for. I could probably clean it up with the primer, but the problem is I'm contaminating the entire can of primer. And if you do a lot of solvent welding as I do, you know that the primer lasts an awful long time, so it would be nice to not contaminate the can. That's what the pool cleaner's for. You use this product to clean up mud or dirt or adhesive residue, all the junk you want on or all the junk you want to remove from the pipe, but you don't want to use the primer to do so. Now that is a connection that's ready for the primer and the solvent cement to make a sound solvent weld that you can be confident with even in a buried application.
The reason why I'm installing a 3-inch suction line for this booster pump is because I want maximum flow. And I've mentioned before that larger diameter plumbing is the key to efficient water flow, and that's true. I even referenced a number which was 6 feet per second of water velocity. Ideally, you don't want to exceed that. Beyond that, there's a sharp increase in your friction losses and turbulence in the water. Fast-moving water moves inefficiently. Slow-moving water moves efficiently. How do you make water move slowly? You make the pipe diameter larger. So here's something that's significant. I'm on a suction side system here. And in addition to 6 feet per second being relevant to flow efficiency, as I discussed, it's also relevant to safety. The VGBA, the Virginia Graham-Baker Act, is an act which stipulates building standards for anti-entrapment in swimming pools. And one of the many things which that act stipulates is that no suction line should ever have more than 6 feet per second of water velocity. And so that's why if I want a system that moves a lot of water, like for example, some massage jets like I'm working on here, I want a large diameter plumbing because I don't want to have a small diameter plumbing line exceeding 6 feet per second of suction line velocity. It's actually really common. There's a lot of existing swimming pools out there that don't follow VGBA standards, but it would be ideal when building and designing to do so, and that's why I'm using a larger pipe diameter here. This is going to allow for up to 138 gallons per minute, which is about 6 feet per second water velocity in a 3-inch pipe. Pay attention here as I start to make these next glue connections. Really scrutinize the job I do aligning this and putting the glue on there, because I have a feeling we're going to be revisiting this later. Was it the extra second I took to loosen that unistrut clamp, you might wonder? Perhaps. I don't know. We'll see. This joint here goes on to potentially be an issue, but I guess I won't ruin the big reveal yet. I'll just let you know that maybe we're going to be hearing some more about that connection I just made. As I'm looking at this and planning out my route for the 2.5-inch return line to the massage jet system, let's talk about this device I'm installing here, which is going to be another FLOWVIS flowmeter. Notably, I already have a check valve on the suction side, as we talked about earlier, and I don't really recommend that you have two check valves like this in any plumbing system. It's really too much of a flow restriction. But remember, this is a test lab. This isn't a swimming pool that I'm installing, and sometimes there's things that I'm doing which are a little different than what you would do for the average swimming pool. And I need to simulate resistance to flow sometimes, and this is one of the ways that I'm doing it here by having more check valves than what I would recommend you to have for your system. It's useful for me. I want and need to know the flow rates that I'm achieving here, but there's other ways that I could have handled doing this rather than have two check valves installed on one plumbing system. So I just wanted to make sure I mentioned that to you so you understand, don't just make a carbon copy of this for yourself. There's some things which would make sense for you to do, but there's some things which would not make sense and I wouldn't recommend for you to do. You don't have a test lab. You have a swimming pool and a hot tub. That's different. It's common in a plumbing system to have a larger suction line than the pressure side line, and that's why you see a 3-inch suction line here on this pump and then a 2.5-inch pressure side line. This balancing is needed for the pump. The pump needs some resistance to flow in order to operate properly, and that's one of the primary reasons why you're going to have a smaller size pressure side line than your suction side line. Usually with a plumbing system, you would only change one pipe size. For example, I've got 3-inch suction, so I would go one pipe size down to 2.5-inch for the pressure side. You don't want to go further than that. I wouldn't have a 3-inch suction line and then go straight to a 2-inch return line. That wouldn't be a balanced system. So commonly speaking, at least for pool plumbing systems, you should only be changing a maximum of one size. Unless you start adding more pipes to the equation, that's how it should be balanced. It's worth noting that the pumps that I'm installing for this system are the Tristar 900 model pumps from Hayward. These pumps are 1.85 horsepower variable speed, and they are, as I've indicated in a different video that I have, my favorite pool pump. That being said, I want to point out that there are a lot of larger, more powerful pumps in the market. Heck, even Hayward makes a big brother to this exact pump, a 2.7 horsepower Tristar 950. And with the size of plumbing that I'm installing here, the current size pumps that I have on here, these 1.85 horsepower, these are like your economy car of swimming pool pumps, which really that's what you want. You want an economy car. Nobody gets enjoyment out of having an extra flashy swimming pool pump. You just want your pool to be clean. You don't want to have any green water. You don't want to overpay for electricity or anything like that. That's why not getting the hot rod of swimming pool pumps is an advantage. You don't want extra horsepower in a pool pump that you're not using, and that's why the more modestly rated 1.85 horsepower Tristar 900 that I'm installing here is the one that I use more commonly. But There are a lot of pumps on the market which are more powerful, including ones that Hayward offers themselves. And these ones can and will exceed the flow rate for a lot of equipment, peripheral equipment that has a maximum design flow rate of 60 GPM, 80 GPM, 100 GPM. All of these are readily surpassed with even modestly sized plumbing. 2.5-inch and 3-inch larger plumbing like this, you easily could exceed those flow rates with these larger horsepower pumps. Being that this is a test lab, I'm trying to build this system such that it could handle pumps of any size and description, including ones larger than these Tristar 900s that I'm installing right now.
All right, let's change your position. All right, let's just work with that, huh?
Let's talk about hydraulic balancing. So right now I have the pressure line coming from the massage jets. And if I'm honest, I wish it were 2.5 inch through to this T that I just installed here. I didn't have the pipe that I needed. If I were to do this all again, that T that I just installed would also be 2.5 inch in size, but instead it's 2 inch in size. So just pretend along with me that it's 2.5 inch. And now we're going to step down to 2-inch pipe in 2 different directions. That's what you see there. We've got a T. And the reason we have the T is the hydraulic balancing that I talked about before. So I'm gonna have 4 massage jets that I install here. And if I just feed them in a row, 1, 2, 3, 4, the furthest massage jet will have the weakest flow. Basically no flow at all. All the flow will just go to the closest jet. And the way that you avoid this is essentially looping of the pipe. So when I bring a 2.5-inch pressure return line to a spa for massage jets, the first thing I do with that 2.5-inch line is I make a full 360-degree loop underneath or around the hot tub. That loop is where I install a bunch of T's, and those T's feed the individual jets. So the loop is the most important part. This is the hydraulic balancing. If you don't have a looped system, you're going to have unbalanced flow, and it's going to be a problem, and you're definitely going to be, unhappy with the performance of your massage jets. And avoid it entirely by just making sure that you loop any pressure line that's supposed to have equalized flow, and that's called hydraulic balancing. So the 4 T's that you see installed facing towards me, towards where I'm standing, these are our 4 massage jets. And now all I have to do is just continue on past the last one and bring that back around to this T that I installed before we began installing the massage jets. That's all we have to do. And now we have balanced the flow to all of these. No matter how much flow we have, we'll have an even distribution of flow approximately between each jet.
Take a look at this. It's the manufacturing seam that I line up there. That's how I know I'm getting the 45 actually true. If it didn't have that, some fittings don't, you can kind of lay it on the ground with a piece of pipe out both sides, and that'll allow you to adjust your true 90 here.
Now I begin the process of putting in the reducing bushings that's going to take me from 2-inch down to 1.5 inches. Most commonly, massage jets are 1.5 inches in size for the water side feed. Much like I did for the swimming pool return lines, I'm going to be installing reducing bushings on these massage jets, which are going to reduce the orifice size down to what it would be like in an actual hot tub with an actual hot tub massage jet. So talking about massage jet systems here, like how many should a hot tub have? And it kind of just comes down to how many people should the hot tub have. That's kind of like the standard. If it's a 6-person hot tub, it'll have 6 jets commonly. If it's an 8-person hot tub, which is the most common size for a concrete hot tub or a custom hot tub application, an 8-person hot tub might have 8 jets. And the most common orientation of those jets would be 1 jet for each seat, except for 1 seat gets 2 jets and 1 seat gets 0. That's the most common. There's always somebody who wants to sit in a spot with no jets at all. The pumps that we use and the flow rates that we get for massage jets in custom concrete hot tub applications, they're very powerful. They're powerful enough to bruise some people, and so leaving a spot open with no jets is always a good idea. And, on the same note, it's always a good idea to have the throne seat that has 2 massage jets where every other seat only has 1. Talking about massage jet systems, if you had an 8-jet system, I would use a 3-inch suction line and a 2.5-inch pressure side line. I find that's a good number for feeding 8 jets. But if you had more than 8 jets, then I would recommend that you increase either the size of the system or break it up into 2 different pumps for 2 different banks of massage jets. So, but most commonly, I would just go to 4-inch suction, 3-inch return line for more than 8 massage jets, or up to 8 massage jets. I would do the 3-inch suction line, 2.5-inch return line. If you want even less than that, like let's say you want 4 massage jets, or maybe you only even want 2 massage jets. If you really only want 2, or you have very little expectation of the actual flow or function from these massage jets, you could, in theory, get by with just using your filtration pump and zoning in, which is adding a valve to the return side, and just feeding these massage jets I'm installing, feeding these just from the filtration pump. But we have a dedicated filtration pump here. It's going to produce one heck of a lot of flow, especially since we only used 4 massage jets here that we're installing. We could have very easily installed up to 8 for the amount of pipe size and flow rate that we're going to generate with this pump. I guess it's also worth mentioning here, you see me installing the water side for this massage jet system that I'm installing, which is definitely needed in every application, but in a real world setting, outside of a test lab like I have here, there's also an air component to massage jets for hot tubs. In addition to this water side, I would also need a loop of air and a pipe that goes not to a pump, but just to an open air source that's a few feet higher than the water level that exists in the hot tub. So none of those things affect flow rate or electrical consumption of pool pumps, and that's why I'm not concerned with them for a test lab environment, but I wanted you to be aware that there would normally be an airline component for a massage jet system like you see me installing here. Okay, here's the deal. I had a little trouble putting this fitting together. Apparently, I'm not as strong as I once was. And maybe it was a little bit of a funny angle, but the case may be it's backed itself out by about 1/8 of an inch. Upon close visual inspection, Supervisor Mario was definitely able to see that there was an air gap and the solvent cement was not sealing all the way around. Now, if I were a betting man, is this a leak right here? I mean, probably not. Like, and this is above grade in my test lab here. It's probably fine. I could probably leave it. And at worst, it's going to be a tiny little pinhole leak, right? No, we're not going to do that. So what we're going to do here is we're going to approach this like if this were a real pool I'm building. Okay, seems like a good way to approach this. If I had this and this pipe was underground over by the swimming pool somewhere, and I'm looking at this and it's like, is this good enough? Oh no, it's not good enough at all. This needs to be redone 100%. I'm not going to take one iota of risk that this solvent cement weld is not adequate here on a buried system for a swimming pool, for anything for a swimming pool. Let's just do this properly and be 100% certain we got this. So I figured this is a good teaching moment. Let's talk about what we're going to do here, because there are a couple of different things that we could do to remedy this problem. And, you know, I think I've got a couple of ideas. Come on. Okay, all of that didn't work. So now what are we going to do to fix the problem, swimming pool Steve? Well, I'll tell you what we're going to do. Let's say that this is a swimming pool we're building, as I've said that's how we're going to approach this. Well, I would just cut this problem out, and I would add a coupling, and I would add a coupling, and then I would just make the repair, and that's it. And I don't have a worry in the world, and it cost me a couple of couplings and maybe another 90. So be it. The thing about this is this is above ground, and there's something that I can do here that I'm reasonably confident that is going to solve this problem with doing even less work than that. So what I'm proposing to do here, I'm going to cut the pipe right here such that I can get a slip coupling, just a regular coupling on right here. And this pipe, I'm actually going to relocate it. I need another hole in the top of this because reaching over here is inconvenient. So I have this one, but my monkey paws are too big to fit in there. So I'm going to actually drill another hole right over yonder, and I'm going to relocate this pipe. It's going to give me a little bit of an access that I can slip my hand into, hopefully for doing water testing and stuff like that. And it's going to facilitate having a little more room to work. I'm going to make one cut. I'm going to put on a coupling here, and then I have this problem area. I'm going to cut it flush with this 90. And as you've seen in other videos of mine, I'm going to heat and strip and remove the PVC from the inside. I'm going to do it very carefully. I'm going to do it without scorching the pipe or getting the pipe so hot that this 90 is going to become misshapen or unreliable. I am confident that with a careful hand and a delicate application of heat, you can strip out the inside of the PVC fitting without breaking the fitting and without compromising the size and security of the slip connection, such that I can make a new solvent weld here and be entirely confident that this is going to solve the problem. So again, that's my above ground repair. If this were underground, you'd have more room to work with. It's a pool. I would just cut and put couplings and solve the problem that way. Let's get started here. We're going to make a cut, leave enough for a coupling. I'm going to drill a new hole. We're going to move this over, add a piece of pipe after we strip out this fitting here. Let's get started. There we go, just a little bit. That one's pretty much good already. Alrighty. So now we got to get this guy out of here. So I'm going to cut it pretty close to flush here, and then we can start heat stripping and pulling that PVC out of there. Okay, let's get started here. So I marked where the glue joint was suspected to have failed. It definitely hadn't failed. We had full contact throughout there. It did slip out a little bit, but I'd bet my bottom dollar that that didn't leak had I left it, but I'm glad we didn't. Okay, so all I got to do now, clean up this joint here, longer piece of pipe coupling, and then our 90, and then our suction line again. All right, let's keep going.
Much better.
Let's go ahead and get started on mounting the Hayward Omni PL automation panel. Okay, now that we have the panel mounted, we can start to think about things like the electrical lines that are going to have to feed everything, the low voltage lines for control. We're going to start mounting the control for the solenoid for the autofill. We're going to start mounting the innards for all of the diverter valves that are mounted right now that are currently empty, waiting for the check valve and flow meter internals to be installed. So we'll install those plus the control boxes that you read the readout from for those flow meters. One right here. We're going to have one up here, another black one there, another black one there, another yellow one there, a whole bunch of them. Very exciting. We're getting really close here. Let's keep going. So here we are installing one of the FLOWVIS digital check valves and flow meters. And this is significant because most people haven't seen the digital part installed. So if we just had the analog, no digital upgrade, we install this guy, bada bing, that's it. And just observe your flow, right? The flow's got to come this way. You wouldn't want the flow to come this way because that's going to be a problem. So when you have the digital upgrade component, we're going to add a single piece here. We've got this little guy here with the readout, and it's going to get installed just like that. So instead of the normal 2 screws on the bottom here, they send you 2 longer ones. So we're going to be installing all the normal ones plus 2 longer ones to facilitate having this readout and transmitter to send the digital message to the control readout box. So let's go ahead and mount all that right now. Now, I'm not cranking the crap out of these things. This is just hand tight, right? This is plastic components we're working with here, not like galvanized steel or something like that. So it takes a little bit of a gentle touch. I wouldn't recommend using a cordless driver on this. This should be done by hand. One down. You should note that, like, here's another example. Here's an analog meter I've got right here. So could I just take this digital guy and bolt it right on there, and would that work? No. Well, yes, and it would work if you were to add a neodymium magnet to the analog flow meter. Upon close inspection of the digital model, you'll see that in order to transmit that information in order to this secondary piece that we're bolting on, there needs to be some sort of method to do so, and the way that they accomplish this is with this tiny little magnet which gets set with a little dab of silicone, and that's all it takes. It is something that you need to order from the manufacturer. If you didn't and you have one and you're like, I have this tiny little neodymium magnet which would fit perfectly, could I just put that in with a dab of silicone? I suspect that you could. But if you're just ordering this, you should just order the digital upgrade kit, which has everything you need. Found another one so I can show you what I was talking about there. So here's what it looks like on one side, right? That's just kind of the normal analog. But on the digital upgrade, you can see there's a little neodymium magnet, a rare earth magnet, inset in there. And so again, that's what you would need to have in order to be able to just bolt this digital readout onto an existing analog FLOWVIS flow meter. Well, a couple more odds and ends to install here and clean it up just a little bit, but we're almost ready for electrical, and that's both line voltage and low voltage for the different features that we're going to be providing power to and then using control circuits to control pumps, AOP, heater, that kind of thing. And it's all going to be run from the electrical load center, which in this case is the automation panel. Okay, one more flow meter to install here, and that's on the booster pump. And you'll notice this one looks a little bit different. It's got the green flapper, and that's because this is not a check valve. I mean, yes, it has a flapper so that we can register the flow that's going through this, but it does not function like a check valve. I already have a foot valve on the suction line, so I don't actually need a check valve here. This is just the flapper style from FLOWVIS for the flow meter. We are ready to install the parts for the LevelSmart from H2flow. We've already got the solenoid here. Basically what we're going to have is a power supply, we're going to have an antenna, and then we're going to have kind of like the little electronic control board that runs the whole thing. So it's a couple of different pieces here, but pretty straightforward. There will be one more piece that gets mounted in the pool skimmer. Oh, I think it looks pretty good. I hope you agree. Oh, I like. It's very nice. All we need to do now is apply a little power and we should be ready to rock and roll. So here we are installing a Hayward GVA 24 motorized valve actuator. And in order to do this, there's a couple of things that we need. First of all, we need a diverter valve, and we've got one right here. So let's just go ahead and pop that handle off of there, and we're going to mount this right on top there. But wait, important. So if you have one of these, you'll see that there's making a little notation here about the shaft on the back side. This needs to be flush is what they're saying. Let me give you an example of not okay. There, I'm just pushing on this here. Okay, you see there? That's not okay. We would have a problem here, so that's why they're saying make sure that that is flush when we make our installation. So what else do you need to know here? You need to know that you need some extra long screws with which to mount this. Now, the valve that I'm mounting to in particular is very large, larger than normal, and as a result, you don't remove some of the existing screws. You would just go ahead and mount that on there using the other screw holes. Normally, for most swimming pool and spa systems, you're actually going to have to remove 4 screws with which to mount this, replacing the 4 screws with these longer ones. Ours is a little easier than that. Go ahead and mount that on there. There we go, nice and solid. And there we go. Now we just have to run the wire back to the automation panel and plug it in. Let's see how long this cable is. This cable appears to be between 18 and 20 feet long. So definitely lots. All right, let's leave that right there. Okay, let's continue on with the installation here. While we have the suction side motorized valve actuator with that Hayward MVA that we installed, let's install a Jandy one this time. It's the same thing, just different manufacturer, and we're going to go right here with it. So step one, let's pull this handle off of here. Well, the time has come to start wiring the system. And what I'm going to start with here is we need a line voltage and then a low voltage connection to each of these pumps in order to control them with automation. So for the line voltage, I'm just going to use a 1/2 inch flex PVC electrical conduit. The low voltage, this is the SP3200 DRCC, and this is the communication cable that comes with the automation-enabled Omni pumps from Hayward. So each of the pumps needs one of these connections. I'm going to, instead of running these directly to the panel, which is normally what you would do, you would run all of these wires directly to the automation panel. Well, the data cable will go directly there, but I'm going to have a brief stop off in these 2 induction ammeters here so I can externally monitor the power consumption of these pumps like I normally do with my test lab here, because that is critical, valuable information that we need to get when we're operating these pumps so that you can realize just how much you're able to save when you're using a variable speed pool pump. Okay, so bunch of wires here. Let's get started. RS485 terminal block to be used for automation control wiring. So that's this little guy right down here. Now, I think we're just about ready to start pulling some wire through these conduits. I can't believe I almost forgot my sign. I suppose I'm going to need some power for that, so let's see what we can do. All right, so we've got most of the wiring located over to the automation panel here, save for a few things. Let's take care of those now. So one is going to be wiring of the HydraPure here, and I guess I'm going to need a service plug here as well. I mean, there's an option to put a service plug in the side of the PL panel here. It's just aiming the wrong direction for my convenience. So I'm going to add an external one and control my swimming pool Steve light off of that. But I do need another flex conduit down to this AOP unit to provide the power for the circuit. And so I guess let's just talk about that for a second. It's not necessarily intuitive. If this is your first time wiring one of these, it's probably not going how you thought it was going to go. You saw a 1/2-inch size port approximately down on the bottom, and you thought, well, that's where you're going to wire it up, and that's not the case. That's actually just an open slip joint. There's no threads there, so if you went in there with a 1/2-inch threaded box connector, wouldn't you know it, it doesn't connect, because that's not where the electrical connection is. In the instruction manual for this, it refers to using 1/2-inch flex PVC conduit as the method to wire this up. And so the two optional holes in the side, on the bottom sides, which is not threaded, is intended to receive this flex conduit with room to spare. So there's, you know, like a gap around it. And then the flex conduit runs up to the electrical compartment located at the very top of this AOP unit here. And I was weirded out by that. I was like, oh, but it's not sealed where the flex conduit enters the case here, but upon opening it and inspecting it, the case is not designed to be waterproof. In fact, it's specifically designed with air gaps for water, presumably, to escape at the bottom, and the gap around the electrical intrusion there is no larger than the purposely installed gaps already, so I don't really have a problem with this, but I do recommend following the instructions and using the 1/2-inch flex conduit for the electrical installation for this. Let's go ahead and just do that now. Take care not to damage the ribbon there. That's something that's also alluded to in the manual. So there for a moment. Okay. That's the point we're going for right there. And to make that a lot easier, let's go ahead and remove that guy. I'd say there's about no chance. Yeah, okay. Let's pull a tape through. Yeah, that's where she'll go once I get the rest of the pieces on there. Okay, on to the next thing. Remember, these boxes here, they don't exist in a normal swimming pool installation. Those are exclusively for me to install inductive ammeters so I can externally monitor the power consumption from each of these pumps here. So you, in theory, your wires would just connect directly there, whereas mine are interrupted by these boxes. So we've got the boxes, we've got the pumps, we have the line voltage, and we have the control circuit that we need to hook up there. Why don't we go ahead and get the cameras moved so you can see what's going on down there. Here we are about to wire the pumps up, and I just want to mention again, don't just look at what I have and then do it. Get an electrician. That's what you should be doing. Yours could be a different situation than this, and you could connect this, and oh, now you cooked your pump, and that's your problem because you did not contact an electrician. So I'm not doing this to show you so you can do it. This is just part of me showing the entire installation of the system. But remember, yours could be different, so don't just make assumptions with electrical. So what I'm going to be doing here is I've got the line voltage coming in. Now you've got these test leads here. Get rid of these things, we're not going to be using that. We're going to make some hardwire connections here. I did a really great job taping this, so now it's really hard to get this off of here. Remember, this is a test lab installation. I install these pumps, change them, put new ones on, take them off all the time. If you're doing this for a permanent installation, you should not use solid wire like you see me using here. You should actually be using stranded wire for motor connections to account for the vibrations of a pool pump motor. On the other side here, we're not going to use that because that would be the regular controller there, and we're not going to be using that. We're going to be using the automation for this system. So I'll give you another control block to use here. And there we go, we're ready to close this one up. Make sure you have the gasket seated properly there. Okay, booster pump is done. Let's move on to the filtration pump. Here I am installing the wired keypad for controlling the automation system. Now, you have a lot of options here as for how you're going to control your new swimming pool and spa automation system. The wired keypad is kind of the default option. It comes with the system, and I'm just going to mount one here on the wall here so that I've got this always available to me. But I think a lot of people would choose one of the other two options, which would be a wireless keypad, or even better, just to use the Hayward app through your phone. I think that's probably the most common way that pool and spa owners are going to interact with their equipment. But that being said, a wired keypad is always a good idea, and I'm going to run this one now. At this point, all that's left to do is just collect the wires from all of my different points of instrumentation and the new keypad and run all of these wires back to the instrumentation panel so that I can wire them in. I want you to know that there's a difference between bonding and grounding as it applies to swimming pool systems. Now, I'm not here to be your electrical contractor. I just want to make you aware that these are different things. I also want to make you aware that you should be hiring a professional to do your electrical installation to make sure that this kind of stuff is done right. Like, for example, if you just followed what I'm doing here, it's probably wrong because you probably don't live in Canada. That's where I live. And for example, we use unshielded bonding conductors like you see me working with here, where commonly in the US you would see a smaller gauge wire, but it would be green shielded. So I'm not here to interpret the electrical code to you. I'm just installing this in my test lab and allowing you to see the process. But I want you to understand that you shouldn't just follow exactly what you see me doing here. You should hire a professional. Well, I think it's about time we start dealing with this bird's nest of wires here, of which I've added another wire. This one here is the temperature probe. It gets installed through a 3/8 inch sized hole that gets drilled into the pipe somewhere between the pump and the filter, or the filter to the heater, not after the heater, needs to be before the heater. And that's all that is here, red and black low voltage wires in the low voltage compartment. And we we might as well just get started here because all this mess is starting to bother me, so time to clean it up. Most of the low voltage wiring is going to be pretty intuitive as to where it goes because it's labeled in the panel. Further, these control blocks here, these terminal connection points, they only really fit in one spot. I think they've made it like that on purpose just to make it a little bit easier for you. And that's, you're not going to have a lot of trouble figuring out where each of the low voltage wires goes. We have the keypad here. It's a 6-pin, and there's only one 6-pin connector, and that's up there, so that makes that one the easy one. This is one of the only questions that wasn't immediately apparent to me, or the answer wasn't immediately apparent. And this is the pump, or the pumps that I'm connecting now. And I have two pumps. So how do I connect both of these pumps? And all you do is you double up the wires. You can twist the two yellows together, twist the two blacks together, and then just put them underneath the same screw. If you have more than two wires that need to go under there, you're probably going to need another terminal block to connect that to use essentially as like morettes to connect everything together. But since there's only two, you connect the two pumps together, and that's how you connect those. Next, I'm connecting the temperature sensors here. There's one for pool, that's water temperature, one for air, that's air temperature, and then the solar if you have that. There's 3 temperature sensors supplied with this kit. The extra one is for solar heater, if you have a solar heater. Otherwise, it's air temperature and the water temperature. So the water temperature we've already installed, that's drilled into the pipe in between the pump and the filter, or in between the filter and the heater. For the air temp, commonly what you're going to see here is it's just going to be cut to length here and dangling 4 inches out the bottom of the panel here, so long as it's not in direct sunlight. It's important that the temperature sensor, the ambient temperature sensor, is not in direct sunlight, or you're not going to be getting accurate readings. So this, we can go ahead and cut this way back. I like to leave them a little bit longer because you never know what you might need to change in the future, but this is miles too long. These temperature probes are not polarity sensitive, so it doesn't matter which way you connect them under the terminal screws here. And that is the suction side, the one on the suction side of the pump. They have a valve too. And then the other guy, wherever it is here, this much, much longer one is from the return side that is much closer to the panel here. So got the one. Flow switch 1. So what I've just connected there are the motorized valve actuators. These are the invisible hands that are going to turn the valves on both the suction side and the pressure side of the system to change in between pool and spa mode. The first one is labeled suction, the other one is labeled number 2. Okay, there we have the two 220 pumps wired in. They do not go onto the high voltage relays. They're controlled through the data and then through a direct wire here. And what else would I mention? I guess I'll point out that I've run 12 gauge and I'm running 20 amp breakers. I actually think that these pumps, most of these pumps are going to call for 14 gauge and a 15 amp dual pole 230 volt breaker. But this is a test lab I'm building, and I'm going to have other pumps, sometimes really powerful pumps. So my electrical system needs to be more robust than yours, and that's why you're seeing perhaps a little bit oversized to what you're seeing in your panel. Panel, pump, lights, heater, pump, service plug. I think that's it. So I'm going to stop here. I still have to wire in. So this would go onto a breaker like this right here. This is a neutral, go onto the neutral bus. And this is what powers your control board here. If everything was off and you came outside, you would turn on this one, and that's going to turn on to this, and it's going to turn on your display. Basically, with that on, this whole thing's dead, nothing's working. So that's what these are, but these are stranded wires, and I also have some more stranded wires here, and I need ferrule connectors for these, not a regular clamp, and because this is an electrical installation, it needs to be done properly. So I'm going to pack it in for the day, wait for tomorrow when I have that, the ferrule connector kit that I need. Otherwise, I think we've come a long way here. It's looking really good. Not too much more to do. Like, I mean, actually, there's a fair bit more to do here because we have other stuff to install. Like, we have the lights, and I don't just want to install the light here. I need to install the lights on the high voltage contactor, and that's what this line here is going to be. This is for my light, not my pool light, but the swimming pool Steve sign. And so that will run off of one of these contactors so that through automation, I can turn that on and off, which is great. The pumps will turn on and off directly via the comm, as I was mentioning, with a direct wire like this. What else did we have here? It's this guy. Oh, wait, no, I'm wrong. So this is not the service plug. This is the AOP. This is the AOP unit, and this will also need to get wired through a high voltage relay. So I'm going to go from, like, let's say this top circuit. Let's say I'm going to make this the AOP. So I'm going to go from the AOP up to the, so it's 115 volts in this case. So I would go, let's say I'm going to use the top guy here. The neutral line goes direct. The hot wire is going to come off the breaker onto here and then off of here. So when the normally open is happening, then you would have no voltage on the secondary. When the contact energizes and closes, you would have voltage on the secondary, thereby providing power through the line to the peripheral device, in this case the AOP unit, the Hayward HydraPure. But as I mentioned, we're waiting for a ferrule connector kit, so we'll just go ahead and set that aside. I think this is as far as we can go today. It's looking really good. It's a lot cleaner here now, which is fantastic. There's a bunch of wiring still to do here on the outside of the panel, but one step closer. All right, now let's connect these stranded wires. I think I'm just gonna leave them full length. Let's see here. Yeah, I can definitely do something there. This guy wanted in the top one. Oh, that works. It works there. Okay. I can hear the rain pounding away outside. And after a lifetime of working out in the field, I certainly appreciate this shop that I'm working in right now. Alrighty, so we got this guy on. Well, I've made another error. All right, so what do we got here? I need the AOP, which is that last one I just did there. That AOP needs to connect onto the load side of that. And of course, now I've cut it too short. Okay. No sense whining about it. Let's get going. Okay, AOP needs to... Somebody get me the cable stretchers from the van. That's a little electrician humor. Okay, so from the breaker to here. From here. Okay. Now, future heater. The light. Did I do it to the other one too? I think I did. Is that this one? No, not that one. Not that one. All right, well, it's got to be this one. Yerp. Oh, Steve. It's early. Give me a break. I was glad I got this fixed before Mario found it. I hate that guy. So now we have the line side feeding to, which relay is this? This relay is number 3. So I'm going to write that down up here. Lights. That's number 3. 1, 2, 3, 4. That's the way that those are labeled. It's actually 1, 2, 3, 4, 9, 10. So if you add more, those are 9 and 10. So this is all depicted on the cover. You can just read it on there. But we only needed the 2 because I don't have any need for high voltage for a heater. I don't have a heater yet, so we're not wiring anything for that yet. Right now, we only have the AOP and the incandescent light, which operate on the high voltage relays. Everything else, like the pumps, like this is pump 1 here, and then number 2 right here, those are going to be controlled through the data up here. think everything's pretty much done. We've got flow switch in the flow switch 1 position versus flow switch 2. That's important. We'll need to know that later. The turbo cell is going to install right here, the salt cell, but we're not going to do that just yet because I need to button all this up first. And we can't do that yet because there's no power here. We need to get some power here, so let's work on that. Just so happens, I have some right here. That was easy. See how we can do this. We can just go like that, but maybe we could try going behind. I think probably that's what I'm going to do there. It's in there pretty good. Yep, I can live with that. That is okay. You're all going to think I'm crazy. But that one is too long. Molto bene. Forte bene. I think we are just about ready to close this up. Everything's wired. Guess I should just maybe write down the breakers here really quickly because we have the light on the bottom. I can't remember which pump was which, so I'll have to hold off on writing that down, but I know it's a pump, so I'll write pump. And then the top side here, we have the AOP, of course. AOP. And then we have empty. Then we have another pump. And then at the top, we have the Omni panel itself. Okay, let's go ahead and button this up. I do need to see that. It's a delicate process of just smashing the heck out of it. Very important. This is talking about your T-cell model. If you have a different model, you have to tell it. It's not going to know that. How does this guy come out of there? Feels like it should just pull out, but I don't want to break it. Yep, it just pops out. Hang there. We're going to close this up for the time being. Change the camera angle and let's clean up some wires. Let's see if we can clean this bird's nest of wires up just a little bit. Now that we are getting near the end here. Okay, so that guy's going to go down there. This guy's going to get twisted up here. This is kind of the messy part here, so we could just deal with this and that would help a bunch. So this is the LevelSmart system here, and this is basically this is the receiver, this is the brain of the operation, this is the solenoid that this is going to control, and we just need to connect these wires here. And I don't think I need a million miles of wire. I normally like to leave them long because, you know, this is a test lab. I might do something different, you know, change things around, but I think that in this case, these are just a little bit too long. Let's see if there's a way I could make that look okay back there. Yeah, if he's back there like that, I can live with that. Let's get this guy out. Well, my heat shrink tubing is too small, and they are all the same size. It's not even going to help me. Thanks for nothing, heat shrink tubing. That's fixed up. I could use another. Okay, and these are our 3 FLOWVIS digital flow meters. 1, 2, 3's already down there. Let's just go step by step here. Oh, I see the LevelSmart has power there, of course, because I've plugged it in, so that makes sense. Now, let's go ahead and turn that off and unplug this guy for now. This unit is going to be doing the 1.5" pipe right here, and I have an FV15. So the dip switch settings here will all come off. So it's 1, 2, 3, 4, off on the left, on the right. Right now, all 4 of them are in the off position on the left. For the FV15, when you look up in the instruction manual, the dip switch settings need to be off, on, on. So that's what I'm going to set right now. On, and the top one's off. So this one is good to go for the flow meter reading ability for 1.5" pipe through an FV15. Now it's worth noting here that this handy little unit can do a lot more than just the flow meter. We can plug in a laptop to this port here, download a program from H2flow, and then we can calibrate this for a bunch of different functions, including setting alarms, setting a green or red LED display based on flow rates that we can assign. There's even the potential to use this unit as an external interlock for things like some sort of peripheral pool equipment which requires a minimum amount of flow, or we don't want it to turn on. This unit here can be calibrated to control a contactor that will allow you to do exactly that. There's a bunch of stuff that you can do with these units, and we're going to deep dive on that in future videos. But for now, in order to read our flow for the systems calibrated to the pipe size and to the meter that we have, we're done here. So we can go ahead and close this guy up. Now here we are with the flow meter that is going to be monitoring the FV-25 that I have for the 2.5" trunk line. So we'll open this up. The default setting for these guys is always 0. So when you have this brand new, the dip switch settings will all be on the left. All of them are off, and you have to assign it for your meter and your pipe size. This one is 2.5" in an FV-25, and that means we want on, off. On, and off. So this guy's good to go now as well. Here we have the third flow meter, and this one is connected to a 2" pipe operating an FVC model flow meter. And the dip switch settings for this one are on, off, off, off. And this one is currently correct, so we're good to go with this one as well. When you're controlling the Hayward Omni pumps through automation instead of the keypad here, we disconnected the keypad control block connected the one for the automation, but there's another step here we have to do. See if it'll focus way in. See those, the blue thing, the dip switches? So these dip switches, the factory setting here, because there's 5 of them, 1, 2, 3, 4, 5, down is off, up is on. Right now, all of them are off, but that's not how it comes. The pump comes like this. There we go. That's normally how it is, and that's the default setting if you've just got this out of the box and hooked it up, but you're going to use automation. Make sure you click that off so all of your dip switches are in the off position. In addition to that, just on the other side here is the individual, the unique number identifier for your pump, the HUA. So make sure that you record that number because you're going to need that number later when we're programming the pump. Installation of the LevelSmart water sensor from H2flow. I want you to see, can you see the water level reflected there? I'm about halfway up that magnetic sensor you see on the front there. And that's what you want your water level to be. So to install this unit, you would first raise the water level in your pool to the ideal water level that you want to maintain. In most pools, that's going to be halfway up the skimmer mouth. You're not going to be dealing with a polyethylene storage tank. You're going to be dealing with a swimming pool and a skimmer mouth. And they very helpfully provide this little tube of AB epoxy here. This AB epoxy, you just squoosh it together with your fingers. Definitely wear gloves because this stuff is not good for you and it gets all over your fingers. So you squish that all up and then you apply that to the back side of this transmitter here. It's got a nice rough texture to it there. I've just used some zap straps to hold mine on in place here at the water level that I have set in the tank. And I haven't used the epoxy because that would be a permanent thing. I don't want to do that. This is probably going to get installed into an actual pool skimmer later. But for now, for this testing lab purposes, all I've done is I've set this unit such that magnet is about halfway under the water, and that's going to be the water level that I want to maintain. Now there's still a configuration process. I can't do this yet because I haven't powered on the system. I need power to the receiver for this transmitter to be working, and how it would work is that when I'm ready, I've powered on all the system, everything's got the juice applied, I go ahead and I just take that magnet off. It's just kind of stuck on there. I peel the magnet off, and you're going to get 3 green blinks out of this top LED there. 3 green blinks, and then there will be a few minutes of a pairing process. And I'll just jump back over, show you what I'm talking about here. So let's say I took that magnet off right now. What we would see is this unit right here would begin the pairing process. Right now you can see there's no power being applied to this at all. Once I get the system up and running and I've powered up the automation system, then I can go ahead and apply power to this and configure it. But for now I wanted to show you how I've installed it and how you would go about installing it in your skimmer mouth such that the water level is maybe about 1/2 inch to 1 inch above the bottom of this transmitter here. Again, I'll just show you that to make sure that there's no errors. So right at the very bottom there is probably not enough. I would want the water level to be kind of the minimum, maybe would be the bottom of my thumb. That's about where I've got mine set there. Getting the LevelSmart system ready here to start operating, there's 2 important points I want to point out. First, this right here manually controls this actuator, the solenoid here. And if I wanted to just manually allow water into the pool, I could do that. And now this unit no longer has the ability to turn off the water supply. So it's very important that this is turned all the way clockwise, nice and snug there. And now the solenoid actually has the ability to automatically turn the water on and off here in this valve. So that's very important, obviously. Here's another important thing. So the way this unit works is that when there's a call for water, it will turn on for a 7-minute cycle. It doesn't continually check the water level through that 7 minutes. It just turns on for 7 minutes. If you have this unit installed on a very small pool, a very small hot tub, pond, or in my case, a test lab, 7 minutes is going to overfill my tank, and that's not what I want. So the way you control that is there's a little standard slot right here, and I'm going to give about 3 turns clockwise. 1, 2, 3. Okay. So what that's going to do is it's going to vastly reduce the amount of water that this unit can release during that 7-minute cycle. If you have a very large swimming pool and you find that this unit is not keeping up with the flow demands that you need, the opposite would occur. You would turn this a little bit counterclockwise, and then you're going to be allowing the maximum velocity or maximum amount of water through this valve during the 7-minute cycle in between when it checks the water level to see if we've arrived back at where you should be. So those are two important calibration points here that I would want you to know about the LevelSmart system from H2flow. I'm not sure what this little guy is here, but I'd be willing to bet that's going to be an air purge or air relief valve. And so we'll just make sure that's nice and snug there. Of all of the things that we are not going to forget to do would be to tighten the band clamp here. It's very, very important. And it's not even just enough to tighten it up. Pretty tight. Now take your trusty mallet. Good to go. In addition to making sure that the band clamp is tight, we also want to make sure our union's snug and ready to go. We want to make sure that the air valve is not open. We want that closed or it's going to be squirting water out. And then make sure that you've properly installed your pressure gauge. And then finally, you can't see it on your side, but down on the back side, there's a drain plug down there. Make sure that you tighten the drain plug. So the final run through here before we start up the system, we got to make sure of a couple of things. First of all, every single valve needs to be double checked that you're not deadheading the system. That would be terrible. So make sure that the valves are all open where they're supposed to be open. Any place that there's a motorized valve actuator, if you reach on the underside, there's a little toggle switch down there with a 3 position. You've got position 1, off, and then position 2. I usually just pick one of the 2 positions as opposed to off, so I pulled that one down, so that's ready to go. Moving on to the pump. Double check all of your unions are tight. That's good. You're all just a little loose. The pumps, the lids are not on yet because the system still needs to be primed. The winterization plugs. Every pump has winterization plugs, usually 2 of them, and you often forget to tighten them. If you don't tighten them, you can have a suction side leak there and it will prevent the system from running properly. Just another one of these things that we need to double check. So we've double checked the valves, we've double checked the unions, double checked the winterization plugs. We're ready to prime these pumps up, but let's just double check the rest of our system before we turn it on for the first time. All right, continuing on with our double check here, out from the filter. Back there, we've got our temperature sensor for water temp. And we come into the valve for the heater bypass. Down would be the heaters on, up is the heaters off for now. Let's just go ahead and turn that off. We'll open up the heater line at a future point. Right now, I'm going to go ahead and leave the AOP lines open. That guy's open. Right now, I have my fill line off. That's fine. Going up to here, we have another motorized valve actuator. So again, we've got one side, middle is off, and then the other side. So I'm just going to click that to this side for now. Make sure that these diverter valves are not deadheading the system. Back over here. All of these guys are open. I will double check that they are tight. It's worth noting as well, so I've double checked all these unions, right? And we're going to start up the system, and within the hour, I'll be able to come to probably every single union on this system and get just a little more of a turn. And the reason why is because right now everything's kind of warm. It's kind of warm in here. As soon as I get this nice cold water circulating through these pipes, the plastic contracts ever so slightly, and you will get another little bit of a turn out of them. That's something that I do with all new pool system startups. Start the system up by tightening all the unions and all that, But then probably the next morning or the next time that I'm there, I'm going to double check all those unions again. You're not trying to crank them so hard that you're going to break something. These are plastic components. But if you can move it with like 2 or 3 fingers, then it definitely needs to be a little tighter than that. Something I didn't catch on video was the connection to the AOP unit for the bond wire. And I did end up getting the right connectors to make that bond wire connection down there as well, with a split bolt connector. And other than that, I think our system is ready to go, ready to start up. I'm excited. And here we are ready for the initial startup for this system for the first time, the Omni PL, actually for all of this stuff. So we'll just start by turning on the mains breakers, powering up all the other breakers, and then we will configure this bad boy together. So far, so good. Okay, that is everything on. So there's going to be an initializing period, then we have to calibrate this touch screen, then we have to look for operating system updates after plugging in the Wi-Fi information for this. So there's a bunch of initial steps, and that's before we can get to even programming all of this fancy new equipment we have. Okay. Don't look at my password, guys. Sure, yeah, that would be fine. Color for the screen is good. All that looks correct. Automatically get time and date from the internet, adjust for daylight savings. All that sounds good. Less work for me. I like standard units. Most of my viewers are in the US, so we go with standard. I like the speed and RPM here. This is just dealer's choice. Whatever you prefer to see your, do you want to see your pump at 100% speed, or do you want to see your pump at 3,450 RPM? It's the same thing. Make sure that you write down that your MSP ID. I have 2 bodies of water because we have a pool and a spa. Select a body of water, press the right arrow. Okay. Start with the pool. That's a decent name. Calling this 20,000 gallons. I mean, you could name it George or Frank or filter pump, whatever works for you. It is a variable speed pump. So that should correspond to the HUA that is inside of the high voltage electrical compartment on your filtration pump. Minimum and maximum RPM, 600 to 3450 is the range. I'm just going to leave it at that. I don't have any reason to change it from that. Minimum allowed pump speed, maximum allowed. This is the same as the last thing, so that's fine. So low pump speed, medium pump speed, and high pump speed. I'm going to change this first one to 25 because it gives me some nice round numbers to work with. I got a 25, a 50, and 100. I like that. This is a starting point anyway. Filter pump off for valve change. So this is a shared pool and spa system. I'm going to hit a button and these motorized valve actuators are going to turn. And in theory, there's a risk of damage to the pump when you are turning valves while the system's running. Like if you were to call me and ask me, hey, Swimming Pool Steve, when my system's running, can I go ahead and just like move the valves around? I would tell you no, that's not a good idea to do that. You should turn off the system, make your changes to your valves and turn the system back on. Some pools it could be a problem for. If you have an uphill pull and you don't have a foot valve or a check valve on the suction side of the system, such that the system doesn't really prime without somebody manually standing there to add water and stuff like that, it might be a problem. And so that's why you might not want the pumps to turn off. For me, I'm okay with that. Power down the pumps, make the valve change, turn the pump back on. That's a-okay for me. Flow monitoring enabled. I'm going to leave this at no for now. I mean, I have external flow meters like crazy here. We'll come back at a different time and explore this more. Enable priming. Yeah, I do want to enable priming because that would be a good idea for most pumps. The duration for the prime, that's up to you. Every swimming pool is unique. 3 minutes sounds good for my system. Freeze protect enabled, might as well because we have it. And so the temperature for freeze protect, I mean, I'm going to drop this all the way down to 32. I'm not worried about this. So first of all, this is not water temperature, this is air temperature. So the point at which the air just reached 32, I'm not worried that stuff is already frozen. It's okay if things turn on here, because what I don't want is all of those days and nights where it's 33, 34, I don't want my system turning on all the time. So that's why I'm going to drop it right down to the minimum there. Okay, I guess it chooses 1 degree above what I set it to. Fair enough. What speed do I want the pump to operate at when the freeze protection comes on? I mean, it could be anywhere. Like in theory, if I've got freeze protection coming on, like, I might have a problem here. So I'm going to go ahead and give it, like a good 85, something like that. Don't want to underdo it, not have enough water flow in the time when I needed it the most. Right now I have 0 heaters. So for now, I'm just going to omit this step. Technically, I have a solar heater, but that's fine. We're going to do a bunch of stuff on heaters later. For now, we're just going to leave it no heaters, no chillers, no sense and dispense. Sense and dispense is your pH testing and then adjustment via acid feeders into the system. So I don't have pH and chemical automation, but it is an option that you can control with this. I do have a saltwater chlorinator. What percentage output do I want my chlorinator to run at? And percentage output for Hayward systems refers to the amount of time. This would indicate 12 hours a day that it's going to run versus, if I cranked it up like that, that is 24 hours a day my system's going to be running. Because this is a test lab and I have a very large salt cell on a very small body of water, I'm going to drop that down to like 3. Don't do that for your pool. 50% probably a good starting point. That's one of those things that you're going to have to be calibrating over time. You don't know how much chlorine your pool needs. Every pool is unique. The amount of sun it gets, how much you use your pool, the size of the pool, all these things are going to change the amount of time that you need your cell running. 50% of the time seems like a good starting point, so you could do that for me. Again, tiny, tiny test tank, so I have to turn mine all the way down here, or I'm going to over-chlorinate. So I have the that cell, I could have done a drop-down menu there and chosen a different cell if I had a different one. That is the cell that I had. If you have a different size cell or a T cell, older model, anything like that, that is where you would make the change. When do I want to receive a low salt warning? Well, the range is normally around 3,000 parts per million, 3,200 parts per million. So a standard salt warning at 2,700 or less is fine by me. You could go with a low salt warning. If you wanted to, for most swimming pools, you're going to be sticking with the 2,700 here. Yes, so it's warning me here that the salt cell that I have connected is for a pool that's 40,000 gallons. Is that correct? That is correct. That is in fact the right salt cell here. So here again, I'm selecting the HUA for the salt cell. I have 0 cleaners on this system. A cleaner would be like a vacuum cleaner system that requires a booster pump. Water features on this system. I do have a water feature, but I'm not sure if that's, you know what, no, this is because it's on the spa, it's not in the pool. So it's asking if the pool has water features. If I had another pump or some shear waterfalls or something like that on the pool, this is where they go, but I don't. Just a regular pool. I do have a light. It is not a universal color logic from Hayward. P is Pentair style lights. Z are Zodiac or Jandy style. I'm just going to call mine incandescent because technically that's what it is. Or it's not technically what it is at all. It's an LED neon light, but I'm controlling it with 115 volts. So I just need a regular incandescent, and that will give me what I want. We can call it lights. You can call it Frank if you want. Okay, which relay do I have that? And this light is under relay 3. High voltage relay 3. Yep. I think that's me more than this thing. There we go. Okay, there's nothing I can configure because it's just an incandescent. If this had been a universal color logic or a fancy color LED light with like pre-programmed light shows and all that stuff, I think I could do that here, but because this is just an incandescent, I don't have that option. How many pool accessories? Well, we have the light, but I think that we just covered that, but we do have an AOP unit. So let's talk about that unit. I'm going to call this one Other because it doesn't have a section for AOP or HydraPure. Let's change the name of this. AOP. No dedicated pump. It is wired to a relay. And it is wired to relay 2. There we go. I do have a valve, but I don't have motorized valve actuators, so it doesn't need to know about that. For all intents and purposes, there is no valve on this one. Freeze protect enabled. I don't need it on this particular unit. Okay, so that's all good to go. Okay, so we've configured the pool. Let's configure the spa now. We'll just leave it named spa. There we go, 1,000 gallon spa. It does share its equipment with the pool. Minimum and maximum pump speeds, I'm going to leave these the same as they were. On the pool configuration side, it does have a spillover, but I'm not really sure how to configure this. Because there is no control for the spillover. The spillover is manually controlled, and if I select yes here, I think it's going to try to automatically change the settings on a day-to-day basis where it's not spilling over and then it is spilling over. But let's just go ahead and try this because it does technically have a spillover. So let's see what we discover here. So suction and return valve actuators. Which ones were wired to which? So one is the return. And then the suction was number 2. The amount of chlorine output that I want in the spa, it's the same for the pool because it's actually technically on the pool side for my system. Correct, everything's still correct here. Zero cleaners in the spa. There is a water feature in the spa. All right, we'll just call it a water feature. Okay, and we're going to call this spa jets. There is a dedicated pump for the spa jets. It is a variable speed pump. That seems fine. Again, I'm going to change this to 25. No valve. Yeah, definitely it should prime for 3 minutes. No freeze protection on that one. Okay, spa jets. No lights in the spa here. I've only got the one pool light. No other spa accessories. I do have an air temperature sensor. There we we go. So air temp, yes. We do have a water temp as well, yes. Yes, we do have a flow switch. And that is on the salt system. And we wired that into flow switch 1 position. I think that I don't need to do anything here. Just double, yeah, okay, so all that's good. Any backyard lighting, you could put backyard lighting on here. I don't have backyard lighting, but that's cool to know that I can add that in here. Other accessories in the backyard that you would want to control. An interlock. What is an interlock? Well, let's say I had a pool cover, right? So I don't want to have the spa overflowing into the pool if the pool cover's on, because that would damage the pool cover. It'd put all the water from the pool and spa on top of your pool cover, and that would be terrible. This is the system that you use to prevent that from happening. So you would add an interlock, and that would prevent the system from running or from sending water to the spa when the cover is on the pool. We don't need that for this installation, but I just wanted you to know what interlock is for. I think that's it. I think that's everything. So let's just try saving and restarting. So now what we can do here is we can go ahead and we can create a schedule. So let's say that just make this nice and easy to follow for everyone. Okay, so from 1 a.m. until 1 p.m. every day of the week, I want to run, so we can use these, that's 25, 50, 100. We set that already. So let's go ahead and just choose medium, 50% speed for 12 hours. That's what I had to do to turn off the pump there. Because of course I've programmed something in, so it's like, great, let's run, let's do it. Let's see if we can finish that schedule. So let's change it from 1 a.m. to 1 a.m. Repeating 50%. So just for now, this is going to run at 50% speed 24/7. Go and start that. Saves it up. It's going to turn on the pump here, so I'm just going to turn that off to stop it for now, because I'd like to video the whole thing of it starting up. Okay, so we have the schedule done. Click on this light here. I can program the light to come on automatically. That would be pretty cool. I don't need that feature. Same thing with, you know, the chlorinator and the AOP. Let's take a look at the spillover setting. Start, when do I want the spillover? Yeah, see, what I should have done is I shouldn't have included that spillover, because my spillover is manual. If I needed to control this, the filtration of the spa water through automation, I have the ability. I've manually built a makeup valve bypass, which I can go over with you, and that's means that I don't really need that. Manually, my system is going to be controlling the spillover of the spa. Technically, I could remove this. Let's see if there's a way to remove it. I don't really see one. Okay, so I'll just get out of there. That's fine. So I don't need to schedule anything else here, because that's all working. Let's see if I can turn on the spa booster pump. Okay, so that works too. Good. Get out of here. Upgrades. I would like to upgrade. Good stuff. Okay, that's it. We're good to go. It would be running right now had I not manually turned the pumps off. So let's go ahead and change the camera angle, and we'll run this system together for the first time. All right, so we are going to configure the LevelSmart here. And all we got to do, pull this magnet off. And that's that. Okay, so now let's go take a look at the sensor down here on the other end. There we go. So it has noticed something's happening here, and this is going to take a few minutes for it to work itself out, but it's going to take the current water level that it's reading, and it's going to establish that as the baseline. This is the water level that you should maintain in the swimming pool. And so it's going to work on that, configure to that, and then ultimately it's going to control this guy. I'll probably get a test run out of this. Normally I think it's going to start up, open, run for a minute, make sure it's working. I actually have the valve feeding this turned off right now, so it may very well open, but it can't actually fill right now because I am already full to water level. But this would normally be open here. This is just because I'm starting up the system for the first time here. So we'll just go ahead and keep watching this guy. See how, I think it's supposed to take like a couple of minutes. And again, this is the solenoid here, that little box back there. That's the power supply that I have run all the way down and then plugged in right here. That's that guy. And so that controls the power to this. This guy sends and receives the signals to and from the skimmer, where you have that transmitter mounted. Oh, look at that. Something happened. I think it just connected to the sensor there, which is good. Okay, and that's it. So it's connected to the system now. Water level's high enough so it's not opening the solenoid actuator. So I saw that you can do a test of the system with this little magnet here. Hold it over this, and that's it. 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5. I feel like that should have initiated this thing. Might have to pull out the voltage meters here. See if I could, I might have a bad connection here somewhere. It's possible. It's possible it's working as well, but I think there's a bad connection there. Okay, turned off the camera for literally 2 seconds. Pulled the electrical tape off of this. I was gonna do some measurements, but I think I have a bad connection there. I just gave it another crimp, and I notice now when I do this, get that magnet right in the right spot there. It's hard to do this with, there we go. 3, 4, 5. Now, boom. And I can hear the solenoid run inside there, doing a little couple of second check to make sure that it's working. Everything appears to be working. So that's good. So everything is now functioning with this guy here. And here we have my new test lab. A special thank you to Weld-On, to H2flow, to Hayward, and to Jandy. This was a big deal to get all of this stuff installed here. I really appreciate the help and support from everyone. Please like and subscribe this video. I tried to make the most comprehensive, the most detailed swimming pool equipment installation video that exists on the internet. That's actually not easy to do. This took a monumental effort on my end, and I really hope that I'm rewarded for that with lots of views and lots of comments, lots of thumbs up, stuff like that. I really hope you appreciate this. I know that I'm going to enjoy making future videos. There's so many more videos I'm going to have to make. This is just the installation of this equipment. And I guess very, very rudimentary setup so that we can get the system running. Like in theory, there's a lot more programming, a lot more dialing in and setting up that we can, should, and will do with this system. But we got our up and running, and I'm very pleased with that. Thank you for sticking around for this whole video. Okay, let's just walk through it from beginning to end so that you understand what we're looking at. So first of all, it's all so busy in here, we'll just simplify it. Right away, we got the one pump in front of me. All this is a big suction line and a big return line. This is for spa jets. So this is a booster pump for the hot tub jets for my pool and spa shared system. With a shared pool and spa system, it is a compromise. You're using one set of equipment instead of two, thereby reducing your cost to install by quite a lot of money. And that's why people make these shared pool and spa systems. That's why I've made this shared pool and spa system, to show you how it all works. As you can see, it's a little bit complicated. I mean, mine's a little more complicated than even most of them would be in the field. But yes, they are a pretty complicated thing. Let's start to demystify that here so I can explain everything. So we've already talked about the booster pump. That's this guy here. So that's nothing to do with the pool system. That is exclusively for the massage jet feature in the hot tub. For the pool side, that's this pump right behind me here. This is the filtration and heating pump for this swimming pool and spa system. We have two suction lines here. This is important to understand. We have one suction line that comes from the hot tub main drains. We have one suction line that comes from the swimming pool skimmer. This is the minimum amount. You could have more of each of those. You could have 6 main drains in your hot tub and 25 skimmers in your pool. No problem. You can do whatever you want to do. We just need one of each of those pipes as the minimum, and we need that on either side of a diverter valve with a motorized valve actuator on it here. And that's what we have. So we have the pool section, we have the hot tub section, we have that flowing into our filtration pump. From here, it goes into our C4030 cartridge filter. Out from there, into a diverter valve down on the bottom, which controls access to go out to the heater and back with hot water, or to bypass that entirely and just continuing up through the trunk line. Now, as we come up through the trunk line here, we've reached another bypass. This is called a 3-zone bypass. And we have the one large valve on the trunk line, then we have 2 smaller valves here. So let's say I didn't want this system to run. I would close it, and I would close it. It can't run anymore. So that's why you would have these bypasses installed here, such that I can take this unit on or offline as I see fit. So coming up through that bypass, we pass through our digital FLOWVIS flow meter. That's this guy up here. This one is monitoring the flow rate through the 2.5-inch trunk line. This is a very important section, but big red circle right here. So we talked about on the suction side of the pump, we had the pool suction and we had the spa suction. Well, this is the return side. This is the return manifold here, and the actuator here and the actuator on that suction line, they work in tandem. They work together. So when you are in pool mode, you draw 100% of the water from the pool. You return 90% of the water to the pool, and 10% of the water is diverted to the hot tub. That allows the hot tub to stay clean. It spills over into the pool. You get that nice little waterfall feature, and that's all how that functions with pool side, spa side. So right now you can see that this is set to off. So this side is our spa side. This side is our pool side. So since this is off right now, all of the water coming through the trunk line goes up to our pool returns. That's what those are there. Those are our swimming pool return lines. And on those swimming pool return lines, the top one has a yellow flow meter. We have a salt chlorination cell further on down the line, some more flow meters down the line there as well, some diverter valves. What's important here is, let's say we're on pool mode. All of the water is coming back to the pool. This guy right here, this little set of check valve and line valve is called a water makeup. And what we use this for is to take some of that pool water and divert it to the hot tub. So that's what these 2 bottom pipes are here. Those are our hot tub return lines. 2 top pipes are our swimming pool return lines. 2 bottom pipes are the hot tub return lines. So we're in pool mode right now. We're drawing only from the swimming pool. The water comes up and hits this. It can't go this way. It has to go this way. So it goes to the pool returns. But we're going to steal a tiny bit of this water going to the pool returns, and we're going to divert it to the hot tub, such that the hot tub overflows and spills over into the pool. And that's what prevents the hot tub from turning green and being stagnant for long periods of time when it's not in use. This valve I'm holding onto here is the valve that would control the amount of water that you have overflowing. Like if I were to close that completely, now no water can go here at all. There is no longer water spilling over in your hot tub. If I open it just a little bit, we have a tiny little bit of water coming over and spilling over in the hot tub. But maybe you're an auditory person and you like the really loud sound of your waterfall overflowing. Well, then we're just going to open this valve right up so all of that water can go through there, and that's how the water accesses the hot tub when we are in pool mode. Now, let's talk about hot tub mode. So pool mode was 100% suction from the pool, 90% of the return to the pool, 10% diverted to the hot tub. In spa mode, we are going to draw 100% of the water from the hot tub and return 100% of the water to the hot tub. The reason why we do that, we have to isolate that body of water because we're going to heat it to 104 degrees, and you couldn't imagine the cost or the amount of time it would take to heat your entire pool up to 104 degrees. You wouldn't want that. So we need to isolate the spa so that we can change the heater set point in an efficient manner and heat up just the hot tub. So let's talk about spa mode. We hit the button, we turn to spa mode. The suction side actuator, which is normally on swimming pool side only, changes. And now we are drawing 100% of water from the spa only. On this thing, we're going to get the exact same thing. Right now, we're off in this direction, but as soon as I turn it to spa mode, it's going to rotate 180 degrees, and now pool side is off, so no water at all can come through this. That means 100% of our water is diverting to the spa return lines. Notably, this bad boy right here is a check valve. That is a one-way valve. Water can only travel this direction, and that's why when we're in spa mode, with all of the water going this way, we don't get any bleeding back into the swimming pool system. Very important. So we've got the spa makeup, we have the pool returns on top, spa returns on the bottom. Digital flow meter recording here. This digital flow meter is going to be operating on this 2-inch pipe right here. This digital flow meter is operating on this 1.5 inch pipe right here. And then finally, we have another digital flow meter down here on this bottom pipe that has my heat bent guitar into it. I hope you like it. I still really like that. So that's the system. The top line here is the one that has the chlorination cell on it, as well as the flow switch for the chlorination cell. Critically important stuff. If you put this in the wrong spot, this unit can be trying to generate chlorine under a no flow situation. That is an extremely dangerous proposition. Something you should avoid entirely by making sure that the flow switch that controls the function of your salt cell is in line. It doesn't actually matter if it's before or after. According to the Hayward manual, it can be on either side as long as there's a straight run of pipe and you have this such that if the cell has flow, it can turn on. If the cell has no flow, it cannot turn on. Very, very important. I think that's pretty much it. Then we've got our return side manifold here. Swimming pool light, of course, is pretty fantastic. Here, let's go ahead and turn some stuff on, why don't we, since we're standing here. Okay, so I'm going to click on pool. I'm going to click on the filter pump. I turned this off manually when I programmed everything, because as soon as it's programmed, it wants to run the program, and then that's loud and noisy, and I wasn't ready for that yet. But I'm ready now. We're going to go ahead and turn that filter pump back on. Right there. Once the pump has primed all of the air out, which you can see visibly through the lid, there should be no air visible there. There's air trapped in here, so you just got to bleed that air out. That's it. That's all it takes. "20 gallons a minute, 20 gallons a minute, 30 gallons a minute, 0 gallons a minute." I think I have it's flashing battery. I'm pretty sure I have a dead battery in there. This one is battery operated. This one is hardwired to electrical, but this is a battery operated unit, and that battery's it's actually been flashing battery at me for like 1.5 years. Pretty sure it needs a new battery. I'm pretty sure as soon as I replace that, we'll get our true flow reading here as well. So that little tiny bit there is now forcing a diversion of about 60 gallons per minute through the AOP unit here. Everything looks really good. Okay, so there, we've got the programming set now. Let's try turning on my light. Oh, I like that a lot. And the light off. And the light back on again. Light back on. Okay, everything's good. I thought I broke it already. Everything's good. Gonna leave that on because that's baller. Now the AOP is off currently. Why don't we turn that on? Ooh, fancy. Oh, that's nice. More of that, please. Oh, it's good. I like it. One more. Wunderbar. Okay, so everything's working. There's only one problem so far that I can see, and it's not water on the floor, so that's a good thing. I can see that these guys are not recording my power consumption, and I know why. They're directional. It's directional for the way that the inductive magnet is placed, and I had lost the instruction manuals to these bad boys years ago, so I picked a direction and we went with it. I figure I had a 50-50 chance, right? Well, Murphy's Law says that I picked the wrong one, and so I just have to go in there and reverse that magnet, and then we'll start reading our flow rates, which is good. Interestingly, I can see some ozone bubbles here being generated because, of course, this AOP unit is both an ozone generator and a UV light, which creates the hydroxyl radicals. But I can both see and hear those champagne bubbles there. I'm going to open this back up, and that will pretty much kill that flow right there. I just heard it click off, so that's because it doesn't have enough flow. Anything for swimming pools requires flow in order for it to operate. You don't want stuff to be running when there's no flow going through there, because you could burn things out, things get too hot, you could have an explosion in the case of something like a salt chlorinator that develops hydrogen as part of the chemical reaction. You wouldn't want to be developing hydrogen in an enclosed space like a piece of PVC pipe. I think you know where that goes. That's not good. So all that stuff's running. Looking great so far. Maybe just one more thing. Let's go ahead and switch on the spa. Spa jets on high. Let's do it. That noise is because my water level's a little low, so the jets right now are just at the water level, so we're getting this noise just once I raise this water level, because of course all of my system here has consumed so much of the water that was in the tank, so now I'll have to refill it through the automatic water leveler. The system is now changing over to spa mode, and then it should restart this filtration pump here as soon as that guy finishes. Just saw a drip of water. Where are you? Something's leaking. I'm sure I just saw a drip. Again? Drip of water is not good. Right there. Tighten that and see if that fixes it. That's it, that was just not tight enough. It's all good there. During this priming cycle here, where the pumps are running at high speed, there's so much aeration of the water happening in my test tank that you can see it and hear it in the pumps here. But this is a function of this being a tiny test tank and not an actual swimming pool or hot tub. $2,500 RPM, achieving about, what was that? 75 gallons per minute. It's actually really good. 75 GPM at 2,500 RPM. I can't wait till I have my power properly configured so I know how much power it's consuming. But for now, I'm pretty happy with this. The system is up and running. Everything's working, except for that guy, which needs a battery. Everything else is working, and I'm very pleased. I guess maybe one last thing I'll do is register the clean system operational pressure for this filter pump. So the pool filtration pump. Just run it at max for a sec, huh? Seven PSI. So we set the green arrow to 7 PSI. And then about 16, 17 PSI is where the red arrow is if the green arrow is at 7. So that lets you know what the clean pressure is now and then what the pressure is going to be when you need to clean it. When the black arrow touches the red one, time to clean your filter. $25.50. $65 GPM at 2,500 RPM. That's actually pretty good. All right. And that's it. There we have it. The most comprehensive pool equipment installation video on the internet. I didn't skip a thing. This video was long as heck, but you want to see all these details. And I hope you found this helpful. If you did, please like this video, subscribe to my YouTube channel, and you can check out my website, swimmingpoolsteve.com. I'd like to say a very special thank you to the sponsors that made this episode possible. And Hayward with Hayward.com, Jandy with Jandy.com, H2flow.net, and Weld-On.com. These are the sponsors that made this happen. If you want to support me, support Hayward, support Jandy, support Weld-On, and support H2flow. These are the companies that make all of this equipment that you see behind me here and enabled this video to happen. I could not do it without them. Thank you so much. Wait, I forgot something. Okay, now we're done. Okay, it's been about 24 hours running this system. I think we need to go back into the programming menu and make some changes. Now that I know a little bit more about how the system is set up and designed to work, I think we can do a better job programming it here. Let's go ahead and just power it up. There we are. Everything's live now. We'll just give it a minute to get started. I guess this would be a good opportunity to take a moment to thank Hayward, who sponsored this video and enabled me to make this and share this content with you. I really couldn't have done it without them, not even close. So it definitely warrants thanking them one more time here. And if you really find this information helpful, which I surely hope you do, please comment to that regard, and I would appreciate it immensely. Okay, so here we are. Everything's started up, but the thing is, we don't want to go back into the normal operation here. We want to reconfigure this thing. So let's see what we got here. So look at that configuration right there. Okay, so basically, why don't we just go into the configuration wizard and we'll start it again. Enter password. I did not have a password. Uh-oh. I wonder what the password is. System info. This top number, which is going to be blacked out. I don't know if it's something that I need to black out, but I'm going to because I don't want you suckers stealing my stuff. That's your password right there. New configuration or edited an existing one? Well, I don't know if the new one deletes the old one or not, so we can just edit the old one, make some changes to it. That's fine. Okay, so the number of bodies of water that we have is still going to be 2, and I want to keep that, so no worries there. Backyard sensors. Let's check out this sensors one here. I definitely want to add a sensor. It is a temp sensor. I want this one to be spa. Okay. This is what I was looking for. So, the filter pump for the spa, in my case, is the same filter pump as it is for the pool. But when it's asking you in the spa section about filter pump, what it's asking you here is, when in spa mode, how do you want your pump to perform? Do you want perhaps less flow or something like that because there's only one small suction line from the hot tub and you don't want to exceed the velocity of water that you should have in a suction line, anything like that. Okay, so spa filter pump. Flow monitoring, priming speed. One of the things I definitely want to do here is I want to take priming off. That's something that, I don't know, probably for you, you should leave it that it will prime every time something happens. Let me make sure that's saved there. Okay, good. For me, especially because I'm in a test lab with pumps lower than the water level, I'm never going to need them to prime, so it's just kind of annoying that they run at high speed for 3 minutes every time I'm making a change or turning them on and off, which I do all the time. So let's see what else we can look at here. Name type. Oh, that's good still. That'll still be good. Our speed spectrum, that's still suitable for me. All still good. I'm going to enable flow monitoring. Water features. Jets. I'm going to take priming off of the other pump as well. And then I won't have that problem anymore where the pumps prime every time I'm turning them on and off. Yep, that is still correct. All that is good. So the spillover is the main thing really that I wanted to address here. So now I can tell you definitively what this means. If you have plumbed in a water makeup valve, a line that shunts in between the pool return and the spa return, such that when you're on pool mode, which is the vast majority of the time, a small amount of water is going to be diverted over to the hot tub, and the hot tub will spill over into the pool all of the time. There are disadvantages to that. It can create problems with calcium staining and efflorescence growth on the hot tub wall where the water is falling. Falling water loses heat quickly. You have a high rate of evaporation. There are a number of considerations. Your pH goes up. It's really something that's not entirely desirable, hence this setting. You don't actually need to have that spilling over all the time. You could, through automation, make that connection. So what happens here is, in pool mode, which is most of the time the system operates normally, if I select yes for spillover here, what's going to happen is that during the times which I program it to do so, it's going to change over and divert some of the pool water over to the hot tub. Now, this is kind of what happens when we go from pool mode to spa mode. The two motorized valve actuators, one on the suction line, one on the return side, they both move in unison, and now we're sucking exclusively from the spa, returning exclusively to the spa. So the thing is, with this setting here, what this does, when the spillover turns on, the suction side doesn't change. You remain drawing water 100% from the pool, but the return side motorized valve actuator does its thing and turns over and diverts all of the water into the hot tub. So basically you'd have a small waterfall happening from the hot tub into the pool. But that's the idea here, is that you don't run that all day and all night. You do it maybe a couple times a day, such that it's going to turn over the water in the spa. And that's the goal here. The goal is to turn over the water in the spa. And I have to say, between the two, between one that runs 24/7 and one that actuates through automation like this, the automation one is superior, but you need an automation panel to do it. Okay, so I'm going to select no, because for my system, I have one built in and for all intents and purposes, I'm going to let it run 24 hours a day. I'm going to let the spa spill over. I can manually turn that off if I want on my plumbing configuration, but maybe at a future point I'll re-explore using the spillover option and using this exclusively to keep my hot tub clean. For now, this was kind of the main change that I wanted to clarify, because I wasn't sure what that was when we were doing the initial setup here. So something else I wanted to look at, so I wanted to make sure that I got that temperature sensor. Let's see if maybe that's in here. No, don't need to add a heater yet. Chemistry. No, have a chlorinator still, that's all good. Okay, let's back out of here. Jump over to the pool. Good, that's exactly what it should be. Good, that's good. Standalone lights. Should be the good. I have the chlorinator. You know what? That's the one I wanted right there. Put that in bold so I can be sure to recognize that one. Yep. And that means I'm going to delete I think that should be good now. Just check and make sure I haven't missed anything here. I was just seeing what that had in there. I don't have any other accessories to add. All right, so I think we're done here. Those were the main changes that I wanted to make, that I have a manual spillover plumbed in so that I didn't need that automatic one, but now we know what that is. It's important you save this now. I am sure. Thank you for asking. Well, I don't need to change the schedule just yet, but I do need to turn it on. Well, actually, you know what? I need to double check everything first. Always double check. I haven't closed some valves, deadheading the pump, something. I'll be right back. Give me a sec. Much nicer now that I've got that program to not see it. That's an example. If I had the priming enabled, it would have done a 3 minutes on 3,450 RPM or whichever RPM I designated. But for me, I don't need that. This is a flooded intake system, so it's already primed, ready to rock and roll here. So we've clicked on, look at this, 862 RPM. I don't know if you can hear it. I'll just be quiet so you can hear the pump running. It's like I'm standing directly on top of the pump. And it looks like we're still getting, just glancing over, we're getting at least 20 gallons a minute through the system, which is crazy. That is 0.34 amps at a 230 volt installation. 0.34 amps of current. That's a crazy low current for getting 20 gallons per minute. These variable speed pumps blow my mind. Let's get back in here and do some more. There we go. That's what I wanted to see, actually. My water temperature. So I still don't have spa water temp here. Let's see if we can't figure out how to make that go. Well, why don't we turn the spa on? Yeah, I haven't put the salt in yet. Ooh, my air temp just came in. Excellent. 74. I guess it takes a minute. Fair enough. That's the one. So from here, from this screen, features, spa jets. So that's where I can turn the spa jets on and off. Okay. So if I swipe that on, now we're going to be in hot tub mode. So what happens here is the pump turns off because I selected that feature. I wanted it to do that. In theory, you don't need that. You could have a system where it just keeps the pump running. And I guess that would be important if you have a system that's going to lose prime if the pump turns off for any period of time. So the valves are configuring now. They were on the pool suction and the pool return. Now they are on the spa section, the spa return, and then the pump should roar back to life here in a second. Probably won't roar, but we'll start up in a second here as soon as the return side actuator stops moving. There. Okay, we are on spa mode now. Ooh, are you enjoying your spa experience? Let me enhance your experience by turning on the booster pump. Also on 860. That's not very impressive jets. Let's get some flow going through the jets here. 1725. Oh, it's so quiet at 1725. I'm just going to step away here and check the flow. So we're at about 45, somewhere between 45 and 50 GPM, which is pretty darn good for how quiet it is and only 1725 RPM. In theory, if you were actually using your spa jets, you'd probably turn them up a lot more. You'd come up here and 2500. Ooh, listen, it's actually still so quiet. That's crazy. I was expecting it to be loud there. All right, let me read that flow rate again. Just under 80 GPM, like probably 78 gallons per minute, and it's currently drawing 3 amps of current with a 230 volt electrical installation. It's crazy how much flow you get for the tiny amount of electricity that these things use. I mean, it gets a lot more if we crank it right up. It's still actually pretty quiet. Again, I'm standing right over top of this pump right now, so I don't need that kind of flow though. My back's already too sore. These jets would be too much for me. There we go. That's the one I want. Alrighty. So really, I'm just going to turn that off because I don't need that running. We still have the filtration pump running because we're still in spa mode. Look at that. It works. So really, it was already done. I was hunting for, maybe I'd configured it incorrectly. I hadn't. It just needed to be switched over to the spa mode and run for a little while so the temperature sensor could register, do its thing, send the signal here, give me that number, and all is good. Okay, so let's go ahead and back out of here. We'll go back to the pool. Oops. So again, pump turns off, suction side, return side, motorized valve actuators do their thing, and then the pump will restart in the pool mode. That's great. Okay, so that was, I think that was everything that I wanted to cover. I mean, there's so much more that we can talk about here. This thing's got a lot of bells and whistles that you really would want to use and learn about for your swimming pool. But in terms of a basic setup, that's what we've got here. We've got a basic filtration schedule. We've got it configured such that we have the features we want. It's operating the way that we want it to operate. I think that we can just go ahead and call this a success now. Thank you for sticking around, and I appreciate you coming back for these updates. And as a result, I'm going to reward you for doing so with some very candid information about this equipment that I've installed. I like to consider myself an above average person in terms of honesty. I can't help myself but be very honest with you. I had 2 different pieces of equipment leak. I started up the system. We're over here, we're talking about this stuff, and after I turned it off, wouldn't you know it, cleaning up for the night, I found some water on the floor. Why don't we go ahead and take a look at that now? Because I don't know how long this finished video is going to be, but it is super long, I'm sure. And this is at the very, very end. And if you're here watching this, then well, I appreciate you sticking around to the very end. Let's reward you by showing you this behind the scenes stuff of the, you know, the stuff that the manufacturers don't want you to see. It's actually not really a big deal, but I think it would still benefit you. Let's go take a look. Okay, so when I was cleaning up, I found some water under the floor underneath the filter. I was like, oh no, did I forget to tighten the drain cap? Nope, I had not forgotten the drain cap was good. So what was happening is I was getting a drip of water out of this air relief valve. And I mean, even when it was all the way closed, and I'm like, oh no, the air relief valve leaks. That's no good. I'm gonna have to do something about this. And so I did, and I'll just tell you, all I did was this, it's actually designed for this purpose specifically. This thing is a 1/4 turn lock, right? So right now it's in the lock position, and if you were to turn it 1/4 turn in the direction where it says unlock, it will unlock. Turns 1/4 turn, lifts right out, and on the underside right here, there was a big plastic wing nut that I just took off. And then I have this air relief valve in my hands, and all I did to fix this problem was I took my garden hose and I sprayed it out. I think there was like a tiny little piece of plastic or something like that in there. I sprayed it out, I put it back on here, tightened the wing nut, hand tight, put this thing back in here, did a 1/4 turn, the leak is gone. So that's fantastic news. I'm happy to hear about it. But I did want to share with you that was a problem that I had. So it might be a problem that you have too. And it was something that was actually really easy for me to fix. I didn't know how to fix that. I didn't know that, you know, I've never actually taken this manifold apart before. This filter is brand new for me here in the test lab, and it was actually really quick and easy to do. So I'm happy that that resolved, and it did entirely resolve the problem. So that's good. Let's move on to the other problem that I had. Okay, so over here at the 3-zone bypass for the AOP, I had a leak coming out of this one, and not from the glue joints, from the diverter handle. It was coming right out through the handle itself and dripping down. I found some drops on the floor down there. I'm like, oh, what the heck? When the pump was on high speed and there was a lot of flow, more pressure, there was a pretty consistent drop, like drip, 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 like way, way too much. Like no drips are okay in my world, especially with the new system installation. I'm like, oh no, this valve in particular is very expensive. It's hard to install here. There's not a lot of room to work with. I sure wouldn't want to have to replace this valve, and I did not. So all I did was I had to drain the system down, which I did. Then I took the screws out, handle off, screws out, and very carefully just pull straight out, and the insides come out here. You have to pay attention to what you're doing here, where your valve handle is oriented, and then subsequently there's going to be a cover here that is controlling where the water is currently being allowed to flow. So you have to observe this thing as you're taking it apart, because you want to put it together in exactly the same way that you took it apart. So that being said, I saw the problem immediately. On the underside of basically with the stem of this valve handle, there's an O-ring. And this O-ring had a slight disformity, like I think it got squished a little bit. It was slightly deformed. But all I did to fix it was I took some silicone-based lubricant, I put it on, put it back on there, tightened it up, we're good to go. No more leaks under any pump flow conditions. And it just goes to show you, this silicone-based lubricant on an O-ring or gasket solves so many problems. You swear, no, this isn't the problem, that's good. Just give it a good slathering of a silicone-based lubricant, put it back together. More times than not, it resolves the problem. It did in my case, and I'm super happy because I wouldn't want to have any problems here, and now I don't. I'm so tired. Seriously, though, that's it. It's no more. That's the end of the video. Roll the credits. Or I don't even think I have credits. Just get out of here. Go on. Get now. Love it.